Okay. So very cool. We have the Discord. Once again, this group is the Houston Linux Users Group. We help people out with Linux and open source stuff. It's not just specific to Python or JavaScript or anything like that. Prior to this class, we actually had a couple of lightning talks. I did one of them on Android. So we were working on the phone level. We actually took the default firmware off a phone and we threw actually my tablet and we put on an open source version of Linux. We handle a lot of different tech problems, so if you have any questions, you want to get like a demo box up and working with Ubuntu or something of that sort, we gave a shout out for that. We're happy to help out. We have plenty of people that would love to help you out with that. We've already done the Discord. If you're not on it, get on it. It's a little Slack-like thing. We can all stay in communication with it. There's a sub-channel thing for Python specifically, so join that too. There's the general one for the group. Little Linux cartoon. Linux because Microsoft is for capitalists running DOS. And that's kind of like the sentiment of the group. But yeah, we welcome people that have Windows because everyone has to get off of it at some point. So we understand that you're just not there yet, and we're happy to get you there. So one of the things that Ed ran the last class, and we covered, I believe, the first 3 chapters, right? And the last chapter we ended up with was functions, and that's kind of where the complexity starts. The first 2 chapters before that, I didn't really think there was any complexity in it. Complexity being things that I define worth, running over again. We have the way of the programmer, the way of the program. That's kind of an introduction. Then we have variables, expressions, and statements. Variables are things you save in a computer. They go into this vague concept, which we don't get into as Python programmers. We call it memory. That's really cool. So I guess we're going to see every time someone joins the Discord channel. Shout out to Karen. There we go. Yes, I will silence that for the next class. In addition, we have this chapter on functions that we ended off with. This is kind of where things start to pick up. And then, of course, with all classes, the rate in which the material becomes complex grows exponentially, right? I wanted to go over some more things about this book. This book is not a very long book if you look at it. There's 244 pages in the PDF. That includes that whole first chapter, which is more or less very slow, and the guy's introduction. And it also includes the index. This is a very small book is what I'm trying to get at. If you really want to dive deep into Python, there's another book by the same company, O'Reilly. It's called Fluent Python. It's literally maybe 3 or 4 times this book size. And if you really want to hit this hard, my suggestion is that it's not for beginners, but I mean it'll definitely take you the full distance from, this book to I want to be the senior level Python programmer. Okay. So we're going to do up functions. I'm going to go over some of this stuff really quick. I heard we had some difficulties. Who here had difficulties with the function stuff or didn't get all of it or doesn't feel comfortable with it? Is everyone else comfortable with functions? Because it looks like we have about a third of the class up on here. I'm just trying to pace this right. Okay. So I'm going to go over this then really quick because the function chapter in this book is seriously 10 pages. So we're going to run through this because I don't want to lose anyone. It's just going to get worse. All right, let's see here. Shift F5. Shift F5. Of course, that's not going to work. Oh, there we go. It's 2 different windows. That's brilliant. All right. So functions are essentially they're just blocks of code, right? You have your program. Think of it like it executes from the top to the bottom, right? Functions are just little pieces of code that you can jump into and they can return something from. So there's really 3 attributes of a function that are the function's magic, and I want to go over them really quick. The first is that they're declared with parameters. Functions take arguments, right? So in order to take arguments, when you declare a function, you say, I have these parameters in it. And this is all the function declaration looks like in Python. You say def, you give it a function name, then you have parameters, and then that's it. So cool. A colon, yes, a colon. Python doesn't have brackets like you would see in other languages. So what Python uses is it uses a colon, right? And that's what you'll see here. And then, of course, subsequent lines in Python are indented. We went over that in the last class. I will only be using PyCharm when I'm doing all of my work. So you'll actually see PyCharm being used today. PyCharm has some features which make this a lot easier, but these are the real takeaway points for functions. If you don't get this, we need to hit on it. So functions take parameters. Parameters are just things that come in. They return things out. Those are the return variables, right? And then they do stuff. That's the code. So ideally, function, you call it with the same arguments, it returns the same result, right? Now there are definitely some exceptions to that. Input output's one. If you're reading from a keyboard inside of that function, then who's to say that you're going to get the same result from that keyboard the second time? But that's the basic part of a function, and it's one way, it's probably the most rudimentary way you can organize a program. So throw in different little compartments that you reuse all over the place into a function, right? And then you can call them wherever you want, and you've created yourself a library, right? We're going to start building on that now. The examples from the chapter that we went over last time, we're going to go through some of them. We hit functions here. Essentially, we start off, what is happening? Okay, that's not, you know what I think that is, actually? Hold on. Yes, that's what that is. All right. There we go. Okay. Let's see that, and there we go. Okay, so we hit this. We have the math compartment here. This is one method that we're talking about. We're talking about how you can make libraries out of functions. These are different little pieces of your code where you can re-enter it. You can organize it the way you want. It's also the way that the core utilities of Python are organized. So when you see something in here like import math, this is actually a module, and that module in it has all different types of things, right? This was also covered in what Ed went over in the last class. But some of those things are in this math module. You'll see in here that we have like math.sin. All of that comes from this module. There's actually a function in there called sin. So when you see something like this, .sin, that's usually saying inside of a module you're going to find this function. Or this is a method on an object. Those are functions, though, under the hood. So we talked about composition in the last class. Composition is this idea that we can compose functions and pass them as arguments to other functions. This starts this concept called higher ordered programming. So when we think of functions as blocks of code, they are, right? But they're also data that can be passed around, right? So if you want to pass a function around, you can do that. And then whatever you pass it to can call it, right? Or it can do other things with it. This is
the function composition. The idea there is just a function embedded within a function. Is that when you say composition?
No. The idea of composition is that you are creating a function by using another function, not necessarily by embedding it. So, for instance, I think in this example they had do twice or something of that sort. We have this thing. We have this repeat lyrics, right? Here's one example of this. So in this book he uses repeat lyrics, and instead of repeat lyrics he calls print lyrics twice, right? Now that's one example of composition, but it's really not a great example because you're not passing the function into it. Ed?
No, not okay.
So in this case, I think both of you have actually said the same thing, except that he's focusing more on how you type it, and you're focusing more on how it's typed.
Aha.
A function within a function. There's that. You get embed or embedding.
So like if you call another function, then it's just, you didn't really do anything where you added a bunch of functions together, but if you call multiple functions in the definition of your function, your outer function is composed of the inner function.
So
it's the opposite of the way the word works in English, in which case it would comprise them. So you're typically, the computer types are off in their own world.
you will learn that Peter has an understanding of English that can blow anyone else's understanding of English out of the water.
Simple compose and comprise are opposite terms, and they screw them up.
They did, way before I was born, and I don't know the difference. But Peter, I remember, my history with Peter goes back 15 years. He can tell you, I remember going over, what, these shots thine with thy gun or something of that sort. He knows quite a bit about this. But yeah, whether it's compose or comprise, when you call functions inside of another function, then what you end up doing is you create these units of code that you can easily reuse, right? That's the key part here. So you can pass functions around, and you can call functions inside of other functions. And what you're doing is you're essentially building up complexity from base components. And whether or not that means you're composing functions to create something more complex, or I don't know.
Does that mean that these are first-class functions, the way they say it?
They're definitely first-class functions. A first-class function just means that you can pass the function around as if it was data. Yes. Did you have a question on this?
No. I was saying is you are kind of wrapping a function around another function and then passing it.
That's definitely right. Yeah.
It can execute whatever is supported.
This term this author used, composition, has an actual specific meaning outside of Python. But the use that he's using it inside of Python, when he does stuff like this, it's more artistic. And he's just saying that you can essentially create things that are more complex with things that are very simple. So you start off defining these simple functions like this, literally print lyrics, and all that's doing is printing I am a lumberjack and I'm okay. I sleep all night and I work all day. You can do it twice. So you're increasing the complexity. You're saying I want to have that stanza twice. So there's really not much to it other than that, is that we're starting off with these basic things called functions, and we're building on that to make things that are more complex. He talks about here variable parameters are local, right? When you pass something into a function, we have this thing called cat twice. It takes two parameters, part 1 and part 2. Parameters and arguments, we're going to keep them as the same thing. Doesn't really matter for this class. So when we have these part 1 and part 2, these two things can't be seen outside of that function, right? And this is actually pretty helpful because it stops you from having to worry about other things mucking with them. So when you see your function declares these arguments it needs, part 1 or part 2 or whatever those arguments are, you can't see them outside of that function. They have no meaning. They're local to that function, right? We go over this concept in this class about scope, and things that aren't local at all, we call them global. And the real problem with things that are global, that aren't local to a function or a module or anything of that sort, is that you have to have total knowledge of the program to know where those things are manipulated, right? You don't have any damage control. Anyone can touch those things, and you don't know where they are. With a function, when you pass those two things in, whatever those arguments, whatever the arguments are and however many you can pass in, you know that after they arrive in that function, the only thing that can touch them is that function, right? So when you look at that function's code, you don't have to go outside of it to know what's happening.
I have a question.
Yes.
Very basic thing, but I need to.
Certainly, yeah.
So what's the difference between a parameter and argument?
Okay. I'm gonna look in some languages and in some parlances. This is a real thing. This makes a difference to them. In this class, it really doesn't make much of a difference. And in Python, you got to remember the higher level up the programming language, right? The further removed it is from the people who care about the minutia and the vocabulary and all those types of things. So, a parameter, right, is something you declare a function to take. A function takes a parameter. The argument is the actual piece of data, right?
One is the variable and one is the value.
One is the variable, one is the value. You can think of it just like that. There's nothing wrong with that.
Which is a variable and which is a variable?
The value is the thing you declare.
No.
The variable is the thing the function takes. The value is the variable.
Out of the parameter and the argument.
The argument is the value. The parameter is the variable.
You say it 3 times real fast.
Yes. Yeah. And really, I think that like the people that really care about this stuff are the math majors, right? Because in math, you define functions. Functions have a specific name. Functions take parameters. Programmers, we're more lax. We're further away from physics, and we just simply say they're all arguments and they're all parameters, more or less. I don't know. Ed, what percentage of programmers in your experience know the difference and actually use the terms appropriately?
About 3.
There you go, 3. So not a big concern, right? Okay. So we're going to move on. Stack diagrams. This is kind of neat. Here's the deal about this. This book is stressing a lot about how you create them. And really, it doesn't matter how you create them because it's essentially, right, created by the compiler, Python. And they're not for you to create. They're for you to read. So you need to know what's happening when you get these things and what they mean, especially the way Python outputs them. But you don't actually ever have to create them, and it's not a useful skill, and there is no right way to create them because every language is going to do it differently. And here's the kicker. While this chapter doesn't tell you that, the author himself will create them differently in the recursion chapter. So learning how to read them is important, yes.
I would argue that while it's not something that you should do for any block of code that you start writing, it is a useful skill because if you notice that you are, say, jumping back and forth between 2 stacks a lot of times, then it's probably an indication that you've got a semantic choice in your code that could be improved speed-wise.
Definitely, yeah. I mean, it's a skill, you know. Like all skills, you're definitely going to get some mileage out of it. But this is a beginner class, so I don't want people to think that when he goes in here and teaches you how to create them like this is the only right way to do it. The basic premise of reading the stack diagram, though, is as such. The stuff at the top is the area where the error was caught, and all of the stuff below it is going down, and it's all potentially the error, right? So if you just think of it like that, you don't have to go into every little component of the stack problem that he's presenting to you. You read this one, and it says file test.py, line 13 in main, cat twice, line 1, line 1, right? That's likely where the error is. If it's not the error, you can go down one more, right? And then here he's got print twice cat. So this thing called cat twice is calling print twice, which is calling print cat, right? If the error was something he created, it could very well be in his call to cat twice. If the error was something the library he created, it could very well be in print twice, right? So when you unravel the stack, the thing at the top of the stack is likely the crap you put there. And the thing underneath it is the stuff you can't see. And it can go all the way down. It's an arbitrary stopping point here, right? So the stack goes from the top where you are in Python land place all the way to the bottom where you hit the Python compiler. And then you go through the Python compiler and you hit your operating system or your operating system libraries, and then you hit your operating system. So it's totally arbitrary, the little piece that you get. But the little piece that you get is the user land, user-created Python stuff. And knowing how to read that, that's likely where your problem is. You know? It's just the state of your machine all the way through. And the reason why I'm going through this is because if someone doesn't tell you not to worry about it, you could really stress out about like creating that kind of crap, and it's just not really relevant, in my opinion anyway, to understanding and becoming a beginner Python programmer. So we have this stuff here. Did anyone miss this? He goes into this cosine stuff with math. I don't really like this book about the angles, especially in this chapter. The last class we did, they went into phi with Greek, and that was crazy to me. And in this class, they have geometry and trigonometry, which is just as crazy to me. It's not essential for beginner examples. If you don't know what cosine does, that's great. It doesn't matter because you'll almost never use it unless you're writing libraries that are geometric. All right. So now we get down to the examples, and some of these examples are good, and I'm going to go over them. And some of these examples are especially crappy, and I'm going to tell you they're crappy when they're crappy because I don't want people that don't understand math to leave this class. That is the worst way to defect from being a programmer. Most of the stuff you will do as a programmer is using someone else's library. If you can read a library, you can be a great programmer. You don't have to understand this, and it's not really bad math, it's just trigonometry and geometry, but you can be even math dumber than that. All right. So, the first one that we have here for this example is we go through and we do there we go, right justify. Exercise 3.1. Write a function named writeJustify that takes a string name as a parameter and prints the string with enough leading spaces so that the last letter of the string is in column 70 of the display. Peter, is that the right use of the word parameter?
Hold on, I wasn't listening because you promised you wouldn't pay any attention to the difference.
Figured I'd have fun with that one. All right, so here's what I came up with, and I'm going to go over this piece of code here. What we have, why did it do that? There we go. Slideshow, start from current slide. Did it because I did it. All right, so what we're doing here is we're creating this thing called leftJustify, and what I wanted to do is we're taking that myString as an argument to the function, right? So you're providing this function myString. Now here's the kicker. If you give it the same myString twice, you're going to get the same output, right? That's guaranteed by looking at this function because we're not doing anything special. That is what we call a pure function. I'm going to go over that a little bit more as we go on. But this is an ideal function. We take this thing called myString, and what we're doing is I'm calculating myString length. And I'm doing that by using this internal length function. That was actually a hint in the problem. That's how I think got introduced into length. So we give length the argument myString, and it tells us a number, the amount of characters that are in the string. That's the length of the string. So then what I do is I say padding equals, right? And I say this empty character, this space. And then I use this repetition operator. So this operator does two different things. When you give it two integers or two numeric values, it multiplies, right? But if you give it a string and a numeric value, it calls repetition, right? The same thing with lists and with tuples, which we'll get into much later. It has this function. When it's not an integer, it means repetition, right? So we want to repeat this space 70 times because that's what it's asking us to do, right? But I don't want to repeat it 70 times because I want to subtract the length of our string. Why? Because if I pad this thing with 70 spaces, then my part of the string is going to be, I'm thinking because your sides are different than mine, it'll be over here, right? And likewise, if I want to have all of that fit in 70 characters, what I need to do is pad it, and then I want it to fit on the inside, right? I want my string to be on the inside of that space. So that's what we're doing. I'm saying 70 minus our string's length, and then I'm simply saying print the padding plus our string. And plus is the way in Python that you take two strings and you make them one string, right? It's called concatenation. So you don't add strings together, you concatenate them, even though you use the addition operator, right? That word is useful. So that's how the first exercise works. Does anyone have any questions about this?
How does my string get given its length printed a certain number of times so that it equals 70 minus?
Because we're not printing my string 70 times. We're taking
I know.
70.
How many times are you printing my string?
Just once.
But if it's 6 characters long, and you only padding is only 6 characters,
No.
you only got 12.
Padding's not 6 characters. Padding's the empty space
Right?
repeated 70 minus the string length. So if the string length you give it,
I see. So you only got your string once,
right?
and everything else is
Padded.
You can do it so that you put your string a whole number of times. Okay.
Yes, but that's not what this is. We're trying to pad the string with spaces.
All right.
So we
okay.
want that string to be on one side of the screen. We have to make all of these spaces for it. The question is, how many spaces do we need? Right?
Yeah.
Does anyone else have any questions on this? Because this is the simplest function that we've probably seen. You know?
Very understandable.
Very understandable. Okay. And what we're going to do here is I'm going to show you how this works. So because I installed the same software I tell everyone to use, and I'm going to at least pretend like I know how to use it myself. We're going to minimize that. And yes, that's a lot of complexity for a beginner class, but we'll hit that up in a little bit. So here we go. We have this thing called writeJustify. Right, this is the function, the very same one we just saw. I'm providing it writeJustify Monty. This is inside of our little PyCharm program. I'm going to go run, and when I hit run, it's going to give me a bunch of options. I'm going to tell it this one, and it's going to say run. I don't actually know it. Can only concatenate string, not into string.
Yeah, cast the right.
Oh wait, this is, no, it's because this is the reason here. I will actually tell you what happened with this. Okay, so everyone doesn't think I'm an idiot. The Python is a unique language in that the people that write Python care a lot more about style than any other language. So much so that they have incorporated a style guide into their official, what they call language, suggestions and addendums and things. They call it PEPs. So this program here, PyCharm, will actually tell you when you're violating one of their sacred style guides, right? Okay, so get this. I don't use their style guide when I write my Python code. I don't tend to use it. I know a few other people that don't use it as well, and I write in other languages. So my string was originally like this, right? And if you look there, string like that, it's called camel case. That's a different style. And if you hold your cursor over it, it'll actually complain about it. And it'll say argument name should be lowercase. And if you look at that, right, it'll tell you there pep8. That's the violation where you can find it. And if you come down here, it'll also tell you parameter string value, whatever. The point is that this pep8 thing, this is like the Python style Nazi guide, right? So all of that stuff is what they want you to do, and I wasn't doing that originally, and I went back and I started doing what they want just so I could teach you according to their little thingy, their style guide. So yeah, I renamed all my variables, and I apparently renamed one of them wrong. Okay, so this should say here my string. Okay, and then I save it, and then we run it, and now we get the same thing right there, Monty. Okay, I'm going to go back here. We're going to click on this, Shift F5, boom. Okay, one other thing I want to go over, and this is a side note. I heard this on the elevator on the way leaving last time, and they said that they like Python because there's only one way to do something, right? The reality is, in every language, that's propaganda. Python is a really great language to be your first one to use, but these are just the methods that I knew how to do the very same thing we just did, right? So the point is, there's a lot of different methods to do something in every language, and we're going to go through some of these methods in this class. But yeah, I wanted to show off some of those methods in which the same thing can be accomplished with even a language as simple as this. Okay, and we had people taking pictures of this, so yeah, that'll be great. The next thing, we're going to go over some of the other examples on this chapter. We have, that's the right justify one. Okay, we have the next exercise is 3.2. It says a function object is a value you can assign to a variable or pass as an argument. For example, do twice is a function that takes a function argument as an argument and calls it twice. So we had the question about composition. This is really, in my opinion, where composition happens. In this one, we're actually declaring a function do twice, right? And it's taking a function as an argument, and it's calling that function twice, right? So in this case, do twice takes a function, and it essentially operates with that. That's a higher level than just actually calling the function directly, because now you're accepting functions as an argument. So he uses that here with print spam. There's this thing, an example of do twice to call a function print spam twice. So he declares this function called print spam, and in it he says print spam, and then he essentially calls do twice with this function print spam. So because that's a lot of times we're saying print here, we have this function that does nothing other than print, and if you supply that function to do twice, it gets called twice. That's all he's showing you. Now here's the assignment. The assignment is type the example into a script and test it, right? So we come back over here and I type the example into a script. We have it right here. Print spam. And then if I want to test it, what I'm going to do is going to call and this one is There you go. That didn't. Do twice. There we go. Do twice, missing one required positional argument A.
You have on the top do twice, that's F.
Ah, yeah. Okay. So the reason why I'm doing this here is he has two different things in there. I'll show you what he's got. He does these problems where they, like, rather than having different exercises, it's one exercise with 5 different subsections, and they modify each. So he says, type this example into a script and run it, right? This is very simple. It's going to run it twice. Modify do twice so that it takes an argument, a function object, and a value, and calls the function twice, passing the value as an argument. So if we come over here, you'll see that we modified this. We modified do twice to take an argument, right? And then this is what it would look like if you wanted to call the function with the argument, right? So do twice is up here. You see here is the function. This is just like the original. Here's the original. This is what he has. And he's asking us to modify this so it takes an argument. So this is what we've done right here. We take an argument into do twice, and then we simply provide it as an argument to these functions up here. So you can take the argument the same way you take the function, and you simply provide it to these functions you're calling. Right? So that's the first point that he has. And then he says and then he says copy the definition of print twice from earlier in this chapter to your script. So we copied the definition of print twice, but I think he has us to change it. It says use the modified version of do twice to call print twice, passing spam as an argument. Use the modified version of This is remarkably different. Here's what we're doing. We're calling do twice, which is right here. That's what we're calling our print twice thing. And what we do here is we call this do twice. This is really, really complex. Explaining this with words, all of these twices. This is something that you don't do in a little bit because you use actual flow control. So you'll use range and stuff like that, rather than just calling everything twice. But what we're doing here is we have this function, we've created it. I'm just going to say function 1. Function 1 calls this other more primitive function, function 2. This is showing his concept of composition, right? Function 1 is taking a variable, and that's something in which it'll call, right? So we have this thing f, and we take it here. So when we call our function, we provide it print. Print gets passed into this as f, and then we call do twice with print, right? So we're going to be printing 4 times. So that's what he's looking for here, except I think I named it wrong. He wanted us to copy it in as print twice and then change it to call print twice. So I called it print twice or do twice. I'm trying to find a better way to say this without having all these twices here, but does everyone see what's going on? We have this function here, which is going to call whatever you provide it twice. We call that do twice. Now we're creating another function that's going to call that twice, right? So the end result is you're calling something which calls whatever you provided twice, and then we're wrapping that around something that calls that twice. So you have 4 executions. So when we call this, we get spam new 4 times, right? And we can provide it whatever we want, this do twice thing.
Those of us who don't have wonderful, wonderful eyes, in between F's and A's and set of parentheses, is there a comma there? What's that little yellow squiggly?
The yellow squiggly is, I think, again, this PEP8 stuff. So it's telling me that it wants a space. And let me see here if I can make this bigger for you. There we go. Okay, that works. Is that better?
Just a comment.
Yes.
F and A are horrible variable names.
Yes, I can see that. That is likely true. So what I've done here is I've given them pretty crappy variable names. He's right. But I think it's also kind of crappy to call everything print and everything twice, and I didn't have a better idea. So I didn't want to say twice anymore, and I didn't want to say print anymore. But what we're doing is essentially let's get rid of that squiggly too while we're at it. What we're doing is we are, and now it's blurry, but we are calling this thing that we provide print twice here, then we're calling this twice, right?
Evan, do a diagram.
Take one of your
board.
sets of twices and just call it repeat.
That's
Do a
probably,
diagram on the board instead of trying to say it words.
I like that. That's actually brilliant.
And now you can say
There we go.
twice.
We just break the book. That gets us done, right? If we
Well,
call
I
it
would
repeat
call it
twice.
Repeat twice.
Okay. There we go. Does that make it clear for anyone what we have going on here? I hope so. Okay, very cool. And I am sorry about that. I was just trying to follow the book's instructions, and I didn't realize how hard it would be to actually read that out loud. Okay.
Even though you did it twice.
Yeah, right? I did it twice, or something of that sort.
You did it twice, repeat twice.
Okay, cool. All right. So the next thing is this grid box. Did anyone even try this problem? We have one person that tried it. Anyone else try it? 2, 3, 4, 5, maybe 5 people tried it. Yeah, this is another one of those. This is actually like one of his better examples, if you ask me. I think that there's some difficulties with this because a lot of the tools that you will learn to make this job dirt simple, he hasn't yet shown you.
Dirt simple?
Yeah.
That's-
That means that this gets a lot easier when you can do
that one,
things.
Okay, I was going to say this in programming never gets dirt simple.
It doesn't. Okay, yes, it gets massively more simple than it is right now. The thing that made this slightly complex to me is because he has no tools in this box, and he says explicitly right here. Yeah, here. This is where he gets me. He says, "Note: this exercise should be done using only the statements and other features we have learned so far," which is not a lot of fun. This book frequently provides you his examples anyway, so you'll find them in links like right here. And if you want to ever cheat, you can go there and see how he did it, right? I'll show you how I did it though, because doing it yourself is more fun. Does anyone have an example where they have themselves done it that they want to go over? If you do, drop it in the Discord and we'll take a look at it. So this is exercise 3.3. Oh, there we go. Okay. So I started off and I declared this thing called, let's crank it up a little bit. We declared this thing called delim, and what I did here is I essentially started off by showing you that little part of this that constitutes what is the delimiter, right? So the way I saw this when I first looked at it is when I took a look at it, I saw the bottom as being the body and the top as being like the header. That's how that came off to me. Right, so I see this line and I see like, okay, that's a header, that's a header, that's a header, or a footer, depending on how you want to look at it. And all this crap in the middle, that's the body. Right, so I kind of just thought that this is like a cell being drawn. So what I did is I declared in 2 different sections, the delimiter and the body. Then I have this thing called termint delimro. Right, now this is where it's different. And this is where it's difficult to think about this without any tools in this box, in our Python box. This is special at this side, right? Because if I just call this piece twice, I don't have this ending column. And I need that ending column. So I created a special little thing to do that. And it's called delim row. This is the delimiter at the end of that row, right? So if I call this, right, all that I'm doing is I'm adding this plus sign at the end of it. And then I have this thing called body row. And it does the same thing but for the body, right? Now I have this thing called self-concat, and Ed's idea was better. We should have just called that repeat, but I didn't, right? So repeat is just taking this string that you provided, and it's calling it twice. So if you give it a string, it essentially puts it back to back, right? Copies it and puts it back to back. So looking at that, what I did is I had on mine a 2x2, and here's how that looks. We have the delimiter row with this delim twice, right? So delim twice and then the ending column. Then I call body, and it essentially does it twice. Just think of that as like repeat. It's a better name for it. And then we have the ending piece of that body, which is that pipe. Right? We call the vertical bar a pipe. This guy right here, because we have to have one of those. So I go through it, and this is how I made mine look. Right? Terminate delim row, and then delim delim. Just we're calling it twice, and then that's how that is. So if I run this code here, run, exercise 3.3, that's what you get, and there's our first piece, the 2x2. Right? So delim row, body row, body row, body row, body row, delim row, body row, body row, body row, body row, delim row. Right? That's how I built it. Does anyone have any questions about that code so far? Does that kind of make sense to you, how I'm breaking this up, how I'm sitting there and I'm looking at it and I'm saying, we have this component up at the top, and then we have this component, which is this body piece, and how both of those match up from here. This is the delim component, this is the body piece with the white space, and then we're just taking it and we're building it from that. Okay, now to do the 4x4, what do? We still have to have these delim rows and these body rows. These are the same, but I need to have twice as much in the body. Right? So I essentially call repeat twice on it, which gives us the 4 thing, right? Just like we saw before. So that's where that's being used. Does this even have, let me refactor, rename, repeat. Sometimes IDEs can just reformat all of that stuff.
It wants you to approve on the bottom.
What's up?
I think it wants you to approve on the bottom one. So do refactor.
Where do you see the... Oh. Yes, do refactor. Haha. Okay, there we go. So taking Ed's suggestion to this, because that is definitely useful. Now what we have is we have this function up here. We call it repeat. It takes a string and it simply presses it twice. So now that simplifies this quite a bit, right? We've gotten rid of that concatenate word. And now we just have the delim row, repeat delim, repeat body, so on and so forth. When we want to make it a 4x2, right, rather than a 2x2, all we do is we call repeat, right? And now notice that this is still a 2x2. But the assignment that we have, the assignment specifically says it wants us to make it a 4x4, right? So it says write a function like this, and then it says down here, write a function that draws a similar grid with 4 rows and 4 columns. So doing the 2x2 is easy. We did that right here. Now we want to go to 4x4 per the assignment. So what I did is I added another repeat in there. But that extra repeat didn't get me where I needed it. It only created a 4x2, right? So what it's creating is it's creating this right here, the 4x2. And we want to have that as a 4x4. So what I do is I go down, and look, I'm just creating more rows. So there we go. Now we have twice as many rows as we had here. We have them here, and then that creates our first 4x4. So the question is then, can we make this cleaner, right? Can we make this, which generates this, even cleaner? And we can. And how do we do that? We use repeat again, right? So this is my final answer. In this, I'm saying what we're doing is we're repeating the whole entire table twice, right? So we create this up here where we're doing the 4x2. And if I simply repeat this twice, I'm going to have a 4x4. So that's all I do. I repeat the top part twice. This is the same code here that you would find up here. Right there. So there's two things we can do. We can take this code which produced the 4x2 and simply duplicate it. Twice as much crap. Or I can just use that same repeat function again. Does that kind of make sense to people? Does everyone see what we're doing? We have this function and it just simply takes one input and it creates an output with that repeated. Right? Okay. Now let's take a look. We can actually go over just for one other piece of advice here. We'll take a look at what he's doing. So he's creating here do twice, FF. This is just like our repeat, right? Except he's using functions. He has do for. He calls this do twice, twice. This is where he's going back into this wonderful world. He calls his print beam. So he noticed the same pattern that I did, right? This thing called beam. And for him, he's essentially using this thing end. And what he's doing here is he wants to print it, but he doesn't want a new line. So normally Python puts out a new line. I don't think he introduces this beforehand. I think he actually introduces this as part of the problem, right? Which to me is almost cheating. So he picked one of his own tools, and yes. See, by default, print advances to the next line, but you can override that behavior and put a space at the end. That's where he introduces this end thing, right? So that's a little trick that he can use to make it easier on himself. And what we have here is, I'm losing it, there we go. So he's using this end piece, and he has this post, right? The post is the way that what he's calling it. So he says he's going to print the beams twice, he's going to repeat it. So he's calling this beam piece twice, right? And then he's printing this. This is how he's doing his end. So he has this function called print beams, which is just like my function that we created, right? Which is delimit row. I created a function that does that. Delimit row takes a string and it puts the plus at the end. And then what I do is I provide that string delim to do it. And what he's doing is he's created a function called print beams. And print beams is essentially saying he needs two beams, which are these, and he needs the plus at the end. So that's the difference in the implementation. And yeah, it's just pretty much the same. I mean, everyone can see where he's going with this. He creates a thing called print grid. It says here he's doing it twice with this print row. A row is one beam and 4 bodies, right? He just has different names for it. Most of his stuff is pretty similar. Okay, very cool. Anyone have any questions about this? Who sent me the thing in Discord? Let's take a look at that. Okay, Derek. Which one's Derek? Derek's our man. Derek actually did his homework. Round of applause for Derek. So Derek's example here, and this is one of the great things that we can actually take a look at it. Derek has, he's using print bar, so he's doing it the same way that the author did it with the end thing. And then he has print column, right? And he's got his columns with the post and then his end piece. And then he declares something called do twice, and he's calling the F piece. So he gives it a function, and he calls that function twice. And then he has, is this the same one the author did? Is this the same one the author did?
I looked at his, and it was very similar.
Yeah, they're very similar.
He used like triple parameters for a couple of functions.
Yeah. So, very cool. And this looks to be very similar to what the author's doing. The only difference is here is that he's creating one for each different type. Right? So he declares them as print 2x4, print 4x4, print 2x2, and then the author seems to be doing it differently. He calls it print 1 beam, print 1 post, and then he declares them like that. But yeah, these are just different ways of composing the same type of grid generation. We break it down into 2 different parts, the top thing and then the bottom thing, which is the delimiter and the post, or something of that sort, or the body, and then we're assembling that, we're composing that into a grid. Okay. Pizzas are here. We want to hit this up now? We're going to go over, I guess, I'll introduce this next piece that we're going to be doing, which is Turtle World. Turtle World is a definitely, it's an old way of doing this. There's nothing wrong with it. It's very good. It's a gimmick, essentially, and what we're doing is we create this concept of a turtle, and we create a GUI, right? This graphical interface for us, and we start to move the turtle around with programming logic. So what we do with Turtle World is we're going to be showing you how conditionals work, how flow control works, how we can move this character, this turtle, right, using a computer programming language. The author introduces this in this chapter with his Turtle World stuff, but there's something important that I learned myself with Python in the process of just like looking at his code. There's a library in core Python, and you can find documentation for it. It's called Turtle. So if we go and we type in Python 3, Turtle, you will find this whole entire Turtle graphics thing, right, where people teach Python using this Turtle. So it's not just the author's idea, and this dates back at least 50 years, right? But the idea of using it in Python is apparently like very big. I don't see this in any other new languages anymore, but this is still the way Python's doing it. You can see here, Turtle graphics is a popular way for introducing programming to kids. It was part of the original Logo programming language developed in 1966. So there we go. It's the 50th plus anniversary of this technology, and we're going to be looking at a newer version of that and how we can use Python to demonstrate some of these like moving of the turtles. Okay, very cool. Pizza's here. I'm not going to get in the way of that. Everyone grab their pizza, and then we'll kick it off.
Did you announce a Discord thread at the beginning of this class?
Yeah, twice.
Okay.
You can find the link on Facebook. If you don't have the link, I can put one up here.
I never can find anything on Facebook because there's so many groups.
Hold on 1 second. Invite people. There we go. This is the link right there. If you can read that, we're good. There we go. Go to that and sign up on the Discord.
Plates are on this end, circle.
Definitely very cool. And then the maker fair was last week.
Yeah, right now and one of them was data science. And then the last one they did was
That is an excellent book. That's one of my favorites. That's a totally
yeah, the last one was
Modern age, we have paper.
He is my.
Am I going to make marks on that?
Johnny was okay.
Okay.
And I don't know, have you ever read a Head First book?
no, I was going to pick up that bundle though.
They're terribly quick and cool, and sometimes that means that it takes longer.
Yeah. I think a lot of this, the more gimmicky it becomes, the more lengthy the process.
Experience bucks for
How long?
ebook camp.
Awesome. It sounded like you were struggling a little bit with the function stuff. Did you want to go over any of it?
Well, no, I'm not struggling with the function. I totally understand.
Right.
My problem is, for example, when you explain, I'm like, oh yes, of course. I did the length. I don't want to go to what the author.
Right.
So no, because I need to understand it.
Right.
And I couldn't. I just sat there and said, okay, how do I say to this that the length is that? I can do it. I was like, okay, I don't know. I read the whole chapter again. I said, it doesn't say here. How do I write
Trying to interface with the old
this?
C,
Right.
And then I went there and I saw it. I was like, okay, it's like that.
So that
But then I came here.
continuing the detective.
I already saw what he did.
Yeah, if you ever have a question like that, even like, because the length function, most of Python is the same as other languages, right? There's not much about Python that's different and unique. So you'll find a lot of Python to be the same thing in like Perl or Ruby, these types of other languages. When it comes to finding the length stuff out, even people that use Python frequently forget about that. So it wouldn't be abnormal for us to just type it into Google, what is the length function in Python? And then it'll come back and it'll say len. Because like, case in point, then
I wanted to do what I want to do is be able to repeat. I take a dive, I take a sage, and I scale the whole thing. There, I don't have to explain it to you. I do my calculation, put it in there, and say, I expect this input, add this X input going.
Right.
And then do that, going, move that file, remove this, put that.
But you got the length of the string, and then you knew the length that you had to fit it into, right? So it should have just been subtracting the big number from the small number, and then saying, I need that many spaces. But the second you do that, you say, okay, I have the length of the string that my string's provided, and I have the length that I need to fill, right? The difference is what I need. I need that many spaces. And then you just work on saying, how do I get that many spaces? And then the answer to that is the repetition operator. And then after you have those spaces, you say, how do I add the spaces to the string that I have? And then that's the plus sign. But after you know the plus sign and you know the length of the string you have and that the string you need, right, you just need to create the spaces. That must have been what hung you up.
I didn't know how to create the line that grandfather the length. When you wrote it, that's when I saw it. It was
right.
Put it there, make a variable, and then put length in the
right.
It's just I can't get my brain to start looking at something and say, okay, I put this here, this parameter, this.
You'll get there, my friend. Just keep up on it. You know, keep looking at stuff and asking how it works, and you'll figure it out.
And when you do it, but after I saw it,
right. Well, sometimes I think I over-explain things, but it's really difficult when the author gives us this do twice stuff, and I'm like, what the hell do I say? Call it
You put in his examples of place, but then he's like, oh, wait a minute, I'm going to use this one. I'm going to use that n equal this, which he hasn't showed us yet.
I think that both of the books that we've done, he goes, they both, my critique is the same on both of them. Is that both of the books that we've done, I think, are not made for beginners, and they go into the weeds too quick. They get lost in the weeds. So
that is what I'm thinking.
I mean, you can give examples that don't involve graphics, that don't involve things like that keep things smaller, you know.
The graphics was easier. That one, the only thing I thought about is doing the beams, and then I saw that the beams is just another line with each of the dots on each of the beams.
Is it okay that I use that? I already did it. But
Yeah, definitely. I think it's a great idea. The only thing is I don't want to have to figure out, you know, tabulating it all. That's the thing is I think that's going to be not fun. Because you're going to have to collect 50 of them and you're going to have to make sense of that data.
Oh.
There's 55 of them.
I don't know. Yeah, I mean.
If we did like a Google thing, it would automatically tell us. You know?
I guess so. And I guess that could be anonymous. I was thinking like you're going to collect over. I guess we could have made an anonymous form.
Yeah.
I guess you could have done that.
Even if it's not anonymous, I think it's totally okay. I mean, like, we don't have to just to say, are we pacing ourselves right or not, you know?
Did you put up something for Discord access just a few minutes ago? Or?
I did, yeah.
Oh, can you put it back?
Yeah. Do you want to do that? Do you want to give them instructions or give guidance on it?
Discord?
Not.
That's just a link. It's all a link for Discord.
I know, but I wanted to, didn't get it. I saw it, but didn't get a chance to copy it.
It's back up. Marco, did you want to give guidance on this? Or just,
I can, sure. You know, I'm thinking we can collect more feedback digitally next time.
Yeah.
So like,
you know how to use Google Docs to create forms?
I can figure that out pretty quickly. You know what? I didn't think about it being anonymous, and I also thought that like, I don't know. I thought that something physical would collect more feedback than something digital. I never leave digital. It's like I've left physical feedback so many times. I almost never leave digital feedback in classes, like in this kind of situation.
Right.
So I was thinking that's why I was thinking that's one thing. But we can do digital next time.
Yeah. Well, alternate or whatever. Give it a shot. Yeah.
The other thing I was thinking about was like people that want one-on-one help with their code, homework, and stuff like that. It's hard to stop the class.
Right.
To do that. Maybe you can mention to come to the social afterwards.
Right.
Bring your laptops.
Yeah, that's a good point. Quick shout out while everyone's eating, and so I don't forget, I wanted everyone to know we all go to Taco Cabana afterward. They have tacos and margaritas and nachos, which are the magic spice of life. If you have any questions about the Python stuff, you're also welcome to get one-on-one assistance there. Bring your laptops. We're happy to help out. Or if you want to show off whatever you're working on, if you've got some geeky interest, That's what it's there for.
Also, I left note cards on everybody's desk for any feedback that you want to leave. If you don't have anything to say, then write, I like pineapple pizza.
No.
For those who know this,
It's called Hawaiian.
Taco Cabana is the one on Shepherd. Yeah. It's like literally 2 exits down, probably 5 minutes away.
Evan, do you already know what the homework will be for next time?
I think what we're going to continue to do is review a couple of these, not all of them, because in my opinion, the ones that we can review and keep the class engaged in are the ones where he doesn't go into the weeds. So if you see something where you're like, oh my god, this is a lot of math, or he's really going into the weeds, probably just skip it, because I would really rather not go over that kind of stuff in class anyway. You know? Certainly if you see a trigonomic function, even if he explains it, just skip it. Ed's going to be covering next week, so I don't know the answer to that. I intend to do at least one more tonight. We're going to go over this turtle world and probably conditionals, and I may touch a little bit on fruitful and then let Ed review it and kill it next class.
I know at the beginning of this, the author said that they tried to model this on just teaching computer science. You think they succeeded? I'm just curious.
I think the last book we did was remarkably good at teaching computer science. The last book that we did was actually pretty good at that, and it was actually not. It was good at that because people left knowing the computer science components of it, and they also left knowing a contemporary language, right? So they left knowing JavaScript, and they left knowing a lot of basic ideas. But in both of these books, they're in the weeds too far, and this book is not teaching much in the way of computer science, right? Yeah, I mean, you remember how comprehensive the last book was, right? It was very comprehensive. This book is a lot lighter, you know.
Sorry, what book was that?
We did eloquent JavaScript.
Okay.
Yeah.
Oh, I have a question.
Yes.
So what do you recommend, like, supplementing this with if we're missing those computer science concepts, but we don't want to learn JavaScript?
It's a good question, and I don't have the right answer for that one,
Okay.
so I'm going to pass on that one. I can say this. If you want to get totally into Python, Fluent Python gets a thumbs up for me. It'll take you from intermediate to advanced. It's 700 pages or 800 pages. It's a massive book, but it'll go over all of the warts of Python, how to work around them, and all of that kind of stuff. Fluent Python.
It's by the same people or same publishing group? Or?
It's by O'Reilly. Yeah. Yes?
Actually, on top of that, I can recommend a pretty good Python book. It's called Python Crash Course. And it's really good because at the end of each chapter, it has exercises where it says, write the program to do this and this and this. And it's very well written, very easy to follow, especially for a beginner.
Python Crash Course? Very cool. Well, I have a question for you on the Python. Do you have a background in computer science, or because is Python Crash Course a good Python book, or is it a good computer science book?
I think it's both, actually.
Right.
That was the first programming book that I picked up, and it's a great read.
Have you been following along with this book, Think Python? Right out. I'm always interested in hearing feedback if you've done both books, you know, which one you like better. The reason why we chose this book is that is Crash Course free and open source? Or is it's a paid book?
Yeah, I got hands on.
Yeah. Yeah, you can definitely get these books, you know, cheap or steal them or whatever too. I mean, I don't have an ethical problem with it. But yeah, this one is actually legally free. Very cool.
Evan, do you like any books that are not from O'Reilly?
I'll be honest, I think that O'Reilly has kind of cornered the Perl and Python market. And the thing is that Python, a lot of these books are very old, right? Very old. Python hasn't changed much, even since the 2.0 days, right? So 3.0, it has changed remarkably little. And you'll find books that are made in 3.0 that may even be as old as, like, I think 2006, 2007-ish. It's like a 10-year-old language. And, yeah, but they seem to, a lot of them seem to be published by O'Reilly. But the Eloquent JavaScript was not an O'Reilly book. Yeah.
Can I make an announcement?
Definitely.
My name is Paul. I work for a oil and gas company as a Linux administrator, and we're actually hiring another Linux administrator, especially someone who knows Python and Perl. So if you're looking for a job as a Linux administrator, come see me. Thanks.
And Perl is remarkably close to Python. It's funny because if you tell the Perl users that their language is very Python-y, they will shit bricks and they don't like that. And if you tell a Python user that their language is very Perly, they will shit bricks and they don't like that. But the reality is, I use both of these languages a lot, and they are remarkably similar. Remarkably similar. So, yeah, you should find it very easy to move from one to the other. And I'd actually throw Ruby and PHP into that mix too, as languages that would be very easy to pivot to. But I think Perl and Python have a lot more in common, you know. I don't know why people get so emotional about that stuff. They certainly do, though.
Like Emacs and Vim.
Yeah. Do you happen to have that same opinion? I assume that you have an understanding of Perl and Python. Do you feel like they're almost... I mean, I think that they're
very similar, but Python is more object-oriented, and Perl not so much. So that's the biggest difference I see.
Most modern Perl users, they use a library called Moose. And I know that I've shown it off to some of the people in the back. And it's actually pretty top-notch. If you come from the Perl world, I highly suggest you check out Moose. The Perl Mongers also meets in this room, by the way, and I think they'll be here tomorrow. So if you check out Houston TM, and they're actually a pretty cool group of people. They're pretty laid back. For Perl users, they bite less. Yeah, the Perl folks call themselves Perl Mongers or Perl Monks or something like that. I mean, back in the day, there was a website called Perl Monks where people used to go to answer and ask questions. And it was like the Stack Overflow before Stack Overflow. And a lot of us are still members of Perl Monks. The Python users call themselves Pythonistas, and it has the same, thing. Yes?
Is there any framework is acceptable to declare local variables?
In Python?
Yeah.
In Python, all of the assignment makes the variable local. So the only catch that I would tell you is that Python is unique, almost, in... I don't think we went over scope yet, right? Let me give you an example here. Let's actually show some code. In a normal language, right, in a non-Python language, let's use that as a less invective way of saying this. Okay, here. There's actually a scratch here, right? So, what's up?
Can you reset the camera?
I'm just going to play around. I think we're going to have some more people outside. I'm going to show something really quick. In a language like Python, if we say this, we create a variable, right, by saying like x equals 5. That's going to make the variable local in Python, right? So if I call foo, this variable x is local to foo. You can't see this variable outside of foo. Right? Now here's where Python is different than other languages. If I say if true, y equals 10, right? And then I come down here and I'm outside of y and I say print y, right? I believe that prints 10. Run, scratch.
But it won't.
Yeah, it's doing syntax.
In foo, name true is not the Okay. Right? So in other languages, this would not work. Right? This thing here, this if statement, is what we call flow control. And we're going to cover that in 2 chapters quite thoroughly. Right? So if is part of this flow control thing where we're essentially creating a branch. Right? We can jump into this branch or we can skip it, jump outside of it. Right? That's what's happening internally. Python will make this variable local to the function that it has. So Python localizes variables to the function. JavaScript and Perl do not, right? So if you want to make a variable local in JavaScript, the only thing you have is the equal sign. There are no operators to do it. The downside of not having an operator to do it is stuff like this, right? It makes it a lot more difficult to have, what people tend to see as like block scope or something of that sort. Does that kind of make sense to you?
Yeah, but my original question was like, is there any time when it's okay to just declare like a global variable for the whole program, or is that just
Like def in closure.
Yeah. So if you're going to declare, the question is it ever okay to create a global variable? The answer to that is not if you don't need to. If you need to do it, you can do it, right? But if you don't need to do it, you're probably better off not doing it. You're probably better off endeavoring a little bit so you don't have them, because it makes it hard to refactor your program later on too when you do that.
In Carroll, I used to make variable local using strict option.
Yeah, Perl has strict. Python doesn't. Right. So this is by the way, JavaScript also has strict and Python doesn't. So this is, we're going to go over this a little bit more. I don't want to like kill it right now. But this concept of global and local, essentially what we have here is if we declare something like up here, y equals 42, to give you a quick example, this y at the top is considered global, right? Let me zoom in so people in the back can see. Y at the top is considered global. That means it's accessible anywhere in your program, right? And this y is going to set the global variable y, because it already exists. Actually, wait. No, it's not. This is going to declare this y inside of this function for you. Right? So the question is,
which y would be like 42 or 10?
this y is going to say 42. This is going to set a local variable inside of 10. I believe that that's true. Let's give it a shot.
I guess the global variable overrides the local.
There you go. 10.
Oh.
So then no, that's actually going to set it.
Yeah, but if you do,
So were there two,
I thought that this was actually going to be required. So this is how you tell Python that you want to use the global variable. But for some reason, it's not even complaining when I don't have it. Run, scratch, does the same thing. Does anyone here use Python and know the reason why this works?
Are you declaring y?
Okay, I'm going to look into this because I don't know the answer to that. That's, yes?
followed through by another print y outside, the second one,
You turn out to
42, right?
After,
Either way, yeah.
so print out for
you want to test if that assignment is working.
So here, the first one is printing out 42. The second one is printing out 10.
no, the other way around.
Yes, 42 is the first one that gets printed. The second one with the foo prints out the 10.
But then
You need a third one.
do it after you do free, see if the assignment's changing.
Yeah. Good idea. I'm liking this cooperation. Run, scratch. There we go. So then the first one is printing out 42. The second one prints out the 10 right here. This is printing out 10.
So what happens now if you do the global compare and assign?
It's going to change the value.
Change the value, right?
That's it. There you go. So then that's exactly what's happening. This y inside the middle right here is declaring a y for the function, right? So that's where Python and Perl differ, is on this treatment. Does that kind of make sense? We'll get into that a little bit more in the future. That's a good question, though, right? So the bottom line is that you don't want to do your global variables when you don't need them, because then you don't ever have to worry about stuff like this, right? Which makes Python code a lot simpler. And here's one of the great things about Python. Not many people use global variables. So you'd find that very seldom in Python code, because it is so object-oriented, right? Okay, cool. All right, hope we're all done with the pizza. Let's move back on to Turtle World. So,
Can you turn the camera back on?
yeah, let's do that. Let's set the camera up.
It's in different places.
I have no idea if that's the right place or not. What?
I don't know. I didn't set it up everyone.
Good enough to me. All right. So who here has set up PyCharm and has Turtle World up and working? Do we have anyone in here who's actually run Turtle World at all? Hello world, Turtle World. We have 1, 2, 3, couple people, 4. Okay, so one of the things that I like about this Python piece is that this PyCharm is that it makes it remarkably easy to set up Turtle World, right? You can come down here and you can go down to settings, and then you go down to your project, and then you can go down to project structure, and essentially what you're going to do is you would select the folder, right, with Turtle World, and you just click sources, right? So that's all that you'd have to do, and after you click the sources button, it makes the Turtle World, the library, available. Okay. I'm assuming, what's up?
I was not able to catch everything.
I'd assume that everyone had it done. I'm happy to do it again. So we're going to go File, and then we're going to go down here to Settings, and then we're going to go down to our project that we have, and we go down here to Project Structure, and you should see here all of your different little things that you have, right, inside of your project. You can select any of them and just go to Sources, and it makes that available.
Control Alt S.
Control Alt S?
Yes.
Okay. Control Alt S, and
It would open up the environment.
yes. And let me. Okay, I already have done it, so I don't know where mine is, but it's there. If anyone is following along, you download a little archive. Let me show you where that one is at too. Turtle World. I think I may have actually bookmarked it. Yeah, Swampy installation. So you go to this page called Swampy installation instructions, and you essentially scroll down to the very bottom, and it says Python 3. And they say Swampy source for Python 3. Right? And then that's what this book is going to use. So this is the file that you want to download. Right? You can take this file here, and you just cut it, and you're going to put it into your project stuff. Downloads.
Pip to install it?
The thing is, no, you can't use pip to install it because it's Python 3.
It's Pip 3, isn't it?
There should be a pip file, but there's not, right? So he says here, Swampy for Python 3 is not available as a package, but the source code is available in a zip file. Swampy source for Python 3 is there. I don't understand why he didn't make this available in pip, but he didn't. So here's the deal. I don't want to mess with this example because I'm currently have this up and working, and I don't want to break it before I get started on it. So I'm actually not going to save any of the changes that I'm making. And what I'm going to do is I'm going to skip it. I forgot to turn this back on. Start recording. Okay. So we have this thing, this Turtle World stuff. and we should just be able to copy and paste his code into it. And if you don't have this up and working, I'm happy to help you get it working. Just hit me up after class or on the next lunch break or whenever, and we'll get you all set up with it. So we create this thing called Turtle World, and essentially we import this turtle, and here's what it looks like. This is his boilerplate code. Run, scratch. There we go. So when you get Turtle World up and working, this is the Hello World equivalent of Turtle World. This thing in the center, this is your turtle. It doesn't look like a turtle, but that's what we're calling it. And what we're going to be doing is telling this turtle how to drive. So we're going to tell it to move forward, make a right turn, all of these types of things. These are different directives we can give to our turtle, right? So let's follow along with the book. And what the book is going to do is we're going to start off and we're going to use this code that the book has got right here. So we created a turtle called Bob, right? We say here import turtle. Bob is a turtle.turtle. And then we say, yes? Do we have a question? Okay, we say print Bob, and then we call this thing called main loop, right? And all main loop does is wait for input. So main loop without main loop, watch what happens, just so people can see this. If you don't call main loop in the code, the library that we have, all that's going to happen is when you run it, it goes away really quick. So main loop is just the piece that makes it wait so you can see it, right? So we go run now, and now we have Bob doing something. And this is how the book is going to teach things like conditionals and flow control. So what we've done is he gives us 3 different instructions: forward 100, left turn 90, and forward 100. Let's go through it again. When we run it, we were pointing this way when we started. We went forward 100, left turn 90 degrees, and forward 100. So this is how we're visualizing our code, right? And this is not a new way to do it. Remember, this dates back to 1966 or whatever. So very established method of showing people computer programming. We are going to copy this code here, simple repetition. Now let's take a look at this code and imagine what it does. We're going forward 100. We already know we're starting off facing right. Forward 100, left turn 90 degrees. Then we hit the second one. Forward 100, left turn 90 degrees.
That's a square.
Then we hit the second one. Forward 100, left turn 90 degrees. And then forward 100. Oh, that's a square.
So that we can see on this.
Yes. Okay, here. But the problem is your left turn and my left turn are different. So I have to do things backwards. So forward 100, left turn 90 degrees, forward 100, left turn 90 degrees, forward 100, and then we're back at the starting point. Did I do that right?
Yeah.
Forward 100, left turn, forward 100, left turn, forward 100. There we go. We don't end with the left turn, though. You just go down to the base point.
Left turn if you want the turtle to be in the same position.
That's exactly right. That's a good point. But the author didn't care, so. But I do like the observation because that is attentive to details. So here, we're going to pop this here, and now we're going to give it a shot, right? There we go. So now we have a problem, right? The problem that the author's trying to show you is repetition. There's a concept in computer programming called don't repeat yourself, right? If you have something like this, right, and you have it 3 times with this left turn 100, whatever, that's something you can eliminate, right? You don't want to write code that many times over to get the same effect, right? So what we're looking here at is wanted to show you this. When we did this grid thing, if you remember, this is the copy where I was writing everything over again. And then right down here, this is the one where I just said repeat. Right? So we're looking again for something like repeat to eliminate all of these useless steps. So here's how we're going to be doing it. And we're going to introduce a new concept, which would have made a lot of the earlier exercises easier. For I in range. Right? So this here is flow control. We now have a for loop in Python. This is how you write a for loop in Python. for I in range 4, print hello. That's going to print hello 4 times. So he's trying to show us now that we can use this for loop to eliminate all of that repetition that we had before. Now if we come down here and we just pop it in once, right? So we have this loop here. It's not in a function. You can just drop a for statement anywhere in Python. We have this thing called for I in range 4, and then we're telling it to do this 4 times. This, by the way, does have the end left turn, and it does return it to the right orientation.
Could you, to help show range a little bit more, do a for I in range 4 with printing?
Yeah, it's a good idea. So here, we're going to say print here, one run.
Print I.
Print the variable I.
Oh, this is because Python is fun. There we go. Okay. Run. There we go. So now you can see each time we run, we see 1 run, 0, 1 run, 1, 1 run 2, 1 run 3. This is each time we run through this for loop once. So we're doing it 4 times. And every time we do it, this variable I gets incremented. So I starts off as 0, and it runs 4 times. 0, 1, 2, 3, 4. Each time we're making 1 turn and moving 100 units.
So for people with no programming background or a small programming background, this is a very important point. Most of the times when you're performing some sort of operation, okay, most of the computer programming environment starts counting at 0. So if you do something 4 times, you get 0 to 3 as the items that are being listed.
It's a good point. And this, I think, gets covered a lot more in the next chapter, which is just over this kind of stuff, flow control.
Not range, by the way.
Range gets covered in 2 chapters after that.
No, I
one.
mean, range doesn't work the same way.
Range, actually, what range does is, if we come over here and we type range 4, it's going to create you this structure, right? We're not going to go into this yet, but that's what range is doing. For the purposes of flow control, we only need to know what happens here and how we're iterating. This is how you write a for loop in Python. In other languages, you would do this slightly differently. But in Python, you iterate over this list, and we're iterating over a list we create. That list we create, we do it with range. Range is going to return a list with 4 items, and the 4 iterates over it. Okay? So, by the way, this would be the same thing as if I did this. 0, 1, 2, 3, but we're not going to, we'll be seeing more of that later, right? So this should work the same way. Bada boom, right? Okay. Anyway, we're not going to talk about range right now. I just wanted to give you that little teaser about it. The point is that the for the first time gives us the ability to run the same piece of code multiple times. And why is this a lifesaver? You guys remember what a pain in the ass it was to say do twice?
Yeah.
Right?
Yeah.
That is absurd. That should never happen. You don't ever say do twice. You just simply say for I in range 4. That makes a lot more sense, right? Because you know what's in there. You're going to run 4 times. That's a lot easier than do twice. Yes?
I have a question about the implementation. Like, in Python, does it implement for you automatically? So, like, you don't have to write I plus?
You do not have to do that, yes. Let me leave the rest, and because you're using terms that we haven't even introduced yet.
Oh, okay.
Let me answer those questions either at Taco Cabana or outside, right? Because I don't want to get too far away from where we're at. Okay, and I shouldn't have done the range stuff either, by the way. That was my own stupidity. Okay, so we have this now. We have our turtle moving 4 times. We can now repeat things like hello, right? And this is the code that we just ran. So now we have exercises. And those exercises are write a function called square that takes a parameter named t, which is a turtle. It should use the turtle to draw a square. Write a function call that passes Bob as an argument to square, and then the program, and then run the program again. Now I already have this stuff all done, but I want to show people how this works. This is very simple, because some people are getting overwhelmed when it comes to writing a program, right?
Yes.
So if you get down and you're sitting down, right, and it comes down to how do I write a program? How do I get started in this? This is something you got to master. The first thing is we need to write a function called square, right? So we know how to start a function called square. All we're going to do is we're going to say right up here, def square. That's a good way to start a function, right? Now we know that function has to take, right, a parameter, right? And the parameter is named t. Okay? So the parameter is a turtle. It should use the turtle to draw a square. So we're coming down here and we're going to add to the function we just created a parameter called t, right? Now what we know we have to do is we have to draw the square, right? We have this code down here. Oh, I don't know what just happened. I hit something and I literally screwed this thing up. Okay, square t, we're doing it again. So now we have this. Now we have to create something that's drawing the square. And what we're going to do is we're going to come up here to see the same code we just wrote. We know that works. There we go. So we have this code here which works. We have a function square, it takes a turtle, and then we say for I in range 4, and we tell it to do those instructions we already understand. Here's the catch. The catch here is that we're calling this on Bob. We're saying Bob forward, Bob left turn. We want to say turtle forward, turtle left turn, because our function square is taking a t, right? So we're just going to delete this Bob and call it t, right? Now if we call square on Bob, we're done. If we spell it right. There we go. Okay. So we go run, and there's our function. Boom, we have a square. So we start off, we knew we had to create a function called square. We knew it had to take a parameter. We already had code that drew a square. The only difference is that code was calling Bob, which was this global. And we want to make it call just the parameter you pass in, that argument you pass in, the t. So we just simply rename Bob to t, and that's it. So now we're done with the first exercise. The second exercise, add another parameter named length to square. Modify the body so length of the sides is length, and then modify the function to provide a second argument. Run the program again. Test your program with the range of values for length. Okay, so now we're adding another argument to our function. I'm going to move this thing up elsewhere. We're adding another argument to the function called length. And now all we're doing is we're replacing this forward thing with length. And now I can say Bob 100. Now this is going to produce the same thing we just saw. But if I come out of here and I say Bob 200, now it's going to be twice as long. Run. Shift F10. There we go. Notice how that square is bigger. Does everyone follow? All we're doing is adding a parameter and we're moving that in. So we added the parameter length and we just simply put it right here. Okay, now we're done with the second part of that. Now it says make a copy of square and change the name to polygon. Add another parameter named n and modify the body so it draws an n-sided regular polygon. Hint, the exterior angles of an n-sided regular polygon are 360 divided by n. So what we're going to do here is we copy this function square, because that's perfect. We don't want to mess with that. And we rename it to polygon. And then we're adding another parameter called n. And we've already said angles is equal to 360 divided by n. Right? Now all I'm going to do here is say left turn angles. And I think what we're going to do is here, this is also going to be angles, right? So now we have the ability to specify how many angles our polygon has. So if I say here polygon, Bob, do I need to, I don't know if that's going to require that. Maybe. Run. Okay. It is going to require that. Good call. Okay, that is not what we want.
It's not angle times, it's numbered n times.
It's not angle.
For the formula.
As you put 4, so he's doing 4 angles, which is just a
Angles is 90 degrees or
Yeah.
not. It should be 4 or 5 sides.
See, this is where all that trig comes in.
Right? Good one. Length, left turn angles, 4i and ring. Okay, so this is all right. I think the difference is, did we switch the order of this? And divide. Let's see here. And I actually wrote this up too. So this is chapter 4.3. 360 divided by n, 4i in range n. Oh, there you go. That's where I screwed up. That's it. My bad.
Of course, you should just redraw over yourself.
Okay, so now what we can do is, if we want to make that something else like an octagon, we would just put that as an 8, and now we have an octagon. Of course, it's too big. So, shrink it.
And left the oh yeah.
I cannot stand this IDE stuff, man. This is blowing my world. Okay, there we go. So, now we got it, right? We made a small mistake, we caught the small mistake, and now we have it. What's up? Yeah, let me make it bigger so people can see it. I think we had, what, 100 before or something?
Yeah.
Okay. There we go. It's our octagon. Beautiful. So that's what we're trying to do here. We're trying to show how we can visualize these programming constructs using Python. And now what we're going to be doing is jumping down to the next piece, which is write a function called circle that takes turtle t and radius r as parameters, and that draws an approximate circle by calling polygon with the appropriate length and number of sides. Test your function with the range of values of r. Hint, figuring out the circumference of the circle and make sure its length times n minus circumference. Okay, so I already did this, and I'm not going to try to explain it again. I'm going to explain it again. I'm not going to try to write it again. We are on 4.3. Actually, we are going to do it again, because that is the advanced one. Okay. Def circle. So now what we're going to do is we're going to try to make a polygon from a circle, right? Essentially, the basic idea here is that a circle is supposed to be a smooth piece, right? A smooth loop. But you could break that circle down into direct lines, right, with angles. So if you say every angle is 1 degree or something of that sort, you can calculate the length of each forward direction. And we can still draw something that's similar to a circle, right? So write a function called circle that takes turtle t and radius r as parameters. That's simple. We're starting with that, right? Circle, it takes turtle t and radius r as parameters, right?
Circle.
There we go. R as parameters and draws an approximate circle by calling polygon with an appropriate length and number of sides. Test your function with a range of values for r. So we're going to call polygon, and what we have to do here is we have to say circumference of a circle. So the circumference of the circle is pi times r, pi r times 2, right? It's squared for areas. Is it pi r squared for the circumference or pi 2 pi r? 2 pi r, right? I don't think it's squared. 2 pi. It is 2 pi r, right?
Yeah, right.
Okay, I just don't want to. There we go.
Area.
No, pi r squared is the area. So anyway, yes, that's so now we're learning about circles, stuff we all should have remembered. So write a function circle that takes a radius r as a parameter and that draws an approximate circle by calling polygon with an appropriate length and number of sides. Test your function with a range of values for r. Okay.
They're asking a different test. They're asking you to use polygon in such a way that you can approximate the circle. Rather
You
than
do
draw
360 pi.
Yeah, that's what we're going to do. We're going to call polygon right here. So the thing is that we have to determine how long the length should be for each one, and we have to determine the amount of sides is simple. That's going to be 360, right? So it should be t circumference. What? Circumference divided by 360? That's right? I think. Side. We're going to give it a shot. T side 360. And let's run that and see if that works. Does that make sense to anyone?
Yeah, I got you. Yeah.
Okay. Run. There we go. Okay. Oof. I screwed up polygon. I almost screwed up circle too. This is really basic stuff. So that's moving slow as dirt, and the reason is because it's literally turning after each angle. So
After each degree.
each degree, that's right, which is each angle.
You say, how come it looks sort of like an oval?
It looks like an egg.
There's arcs.
Yeah, it looks like an oval
Arc
instead of
after
a
each
circle.
arc of 1 degree. Yes.
All of them have been that.
What's the question?
It looks like an oval instead of a circle. Is that
All the
you know why
graphics
that
have been
is?
stretched.
I think that
I know the
maybe
answer to square. It's your screen.
my screen is 4 by 2. That's 16 by 9 or whatever, and that's the answer for that.
So the, you know,
So fix it.
No.
compensate for it.
Evan, is your
I actually think it's the TV's fault on that. I'm not going to bother with it, but there's a mode on the TV there.
Certainly not the
Yes.
programmer's fault.
Yes, yeah. On my laptop, it is a circle. The TV should have 2 modes. One of them should be stretch, and then the other one should be like fit, you know? And what's happening is it's using that stretch mode because my computer is sending it the signal by 14 by 9, and that thing is saying, I don't want black bars on the right, so just pull it. So the TV's screwing me up on that one. So yeah, now we have our circle. Now we're going to move on down, and the circle's actually not bad. This is where it starts to get a little ridiculous. And remember what I said, this is not the kind of stuff you're going to find yourself doing with most programming jobs, right? Creating graphics libraries. So rest assured, this is pretty fun, yeah. Make a more generic version of circle called arc that takes an additional parameter called angle, which demonstrates what fraction of a circle to draw. Angle is in units of degrees. So when angle equals 360, arc should draw a complete circle. Okay. And this is 4.3. So what we're going to do is, I think this is the one where I kick this up, 4.3. Arc, yes, okay. I'm going to copy this. And then we're going to go over it. Okay, so arc is taking the turtle, the radius, and the angle. And the difference here is that we're also calculating the circumference in the same way we did before. Except previously when I wrote it, I had more digits, but whatever. We're dividing the circumference by 360. This is going to tell us what each 1 degree, how long each 1 degree line should be, right? And then what we're going to do is say for I in range angle, and I'm going to say go forward that length and then turn 1 degree. So this is going to allow us to draw an arc, right, without using polygon. And the reason why you can't do that with polygon is because polygon always assumes it's going to be back at the starting point. So with polygon, if we look at this, we always make the assumption we're doing 360 degrees. But if we're building an arc, we're not going 360 degrees, right? We're just going arc, however many degrees are in the arc. So we need to have a function that does just that. So that's what this arc does, is it starts off without the presumption that we're going 360 degrees. So now we can call it, we can say arc, bob, right? We'll give it a radius 50, and we'll say go 90 degrees, right? And now when I run this, you're going to see Bob go only 90 degrees, and he stops. Now we're drawing arcs. So the component in the arc that we had to reject from polygon was that assumption we're going all the way in the circle. Okay? So, does anyone have any questions about that? Does everyone kind of see what we're doing, how we're making sense of this? If the geometry seems a little stupid, it is, but that's just the cute way we're running about things. Okay. Ed, do you have anything to add to that? Kind
Not really.
of. Okay.
This is not the efficient way to draw a circle, but that's fine.
Yeah, we're horrible at writing graphics libraries. Let me tell you, it's beginning Python. Just isn't the right way to go about that. I think like one of the assumptions that if you wanted to make this faster is we could increase the degrees from 1 to 10, right? Is that what you're talking about, Ed?
What's that?
Increasing the degrees for each turn from 1 to 10 or something?
No. It's just that if you're trying to rasterize a circle, then they're far, far more efficient.
Yes, granted. So this is actually going backward a little bit. We're showing you how to put this code inside. He's calling it encapsulation. When we first started this off, we showed how to draw a square, and I think it actually came up. I think you said we're going to start off with a function, and I said no, we don't need a function. We can just throw the for loop in the code. This is where he comes over and he says we can actually take that for loop after we've created it and just wrap it in square. So he's calling that process encapsulation, right? He's just turning that code that we had hanging in there into a function. But now he's showing you this new thing called generalization, and he's saying that in the generalization we added the parameter to the square, right? The length. So what we did here is we made the function more general. We took out one of the presumptions. And he's showing you in each different step of this, in each one of these exercises that we did, we're going through and we're showing, why is this being so ridiculous? Okay, there we go. In each one of these exercises, we're showing how we can make this more abstract and useful in other contexts. So we started off, we wrote a function called the square, then we added to it this thing called length. When we added to it the parameter length, we removed one of those assumptions inside of the function. We no longer assume we're going to want to draw a square of this length. Now we can provide it a length for the square, right? Then what we're going to do is we remove the assumption that the thing we're going to draw is 4 sides, right? When you remove the assumption that what you're drawing is 4 sides, all you have is a polygon. You know you're going to end up at the same point you started, but maybe you don't want 4 sides, so it's even more abstract. So now we can create something called polygon, which takes an arbitrary amount of sides and an arbitrary length for each side, right? So this is part of his process in this chapter called refactoring, where we take code that is specific to one application, drawing a square of length 100, and we make it more abstract. Now it doesn't have to be length 100. Now it doesn't have to be a square. Now it doesn't have to come all the way back to the starting point. Each step, our code is useful in more situations. So in the third step of this, right, we went to the polygon, and then we created this. We created the circle thing, right? And the circle component of it that's cool is that in the circle, we picked an arbitrary amount of segments. So the segments weren't dependent. What is? No. No. Okay. The circle component, what he's showing here is that the circle component internally can use polygon. So when we made polygon, abstracted from square, now we can use that implementation when we want to draw a circle. We couldn't use square to draw a circle, but we can use polygon to draw a circle, right? So we're taking it one step, we're showing you one other reason why you'd want to do it. So if you come down here and you show this original code, square, and you go, okay, I understand you want to have a length here, but if you're only ever going to draw a square, why do you want to create something that draws a polygon? Well, the very next thing that we're doing is we're drawing a circle. And the circle can use the polygon, but it cannot make use of the square. So you can write a square in terms of a polygon and a circle in terms of a polygon, right? But you can't do either one of those things with a square. So what we're showing in this is that each one of these steps we're doing, where we're rewriting this code, we're making it more useful in other places, right? Okay, now the refactoring component is with the arc. So if we look here, we have circle and we have arc, right? And he's showing you here, this is one copy of his arc. So you can make an arc that looks like this, right? And it has this 4i in range step thing. But he's saying that this 4i in range component is just like the one in polygon, right? So if you write this arc and it looks just like polygon, what we can actually do is one more time we can create this thing called a polyline. And the polyline no longer has the assumption you're going to end back where you started. And I see I'm losing a lot of people here, and that's because shapes suck, right? I mean, this is like the big problem with this. I'm going to get back. The polygon starts and ends at the same point, right? The polyline doesn't. So if we can abstract out a polygon into a polyline, we can use the polyline for the arc, the circle, all of that kind of crap.
So this is some terminology that if you do graphics work, you would understand a little bit more easily. When I stood up the first libraries, one of the primitives that you would draw is a point, and another primitive is a line. Polyline is a bunch of line segments that are connected to each other. And so this is the reason why it's maybe not the best name to use right next to polygon. It's a different concept. You know, polylines draw many lines connected. Polygons, they're geometric construct that's different.
My goal is going to be to rush through this a little bit faster because I think it's really in the weeds, guys. It's a bunch of crap, and the bottom line is, like, look, I'm just trying to be honest, right? I mean, I want to teach programming. I don't want to teach this stuff. The stuff. How many people here are in GIS or have ever used GIS? We have 1, 2, 3. I'm actually one of the authors of PostGIS. I love this stuff. I just don't like necessarily being thrown into this when I'm literally explaining how to refactor code. That's not a good place for it. So how many people, can anyone here name what GIS even stands for? Information systems, right? In geographic information systems, knowing the difference between a polygon and a polyline is 101, right? The amount of programmers that know the difference between a polygon or a polyline or even know what a polyline is 1 in a million. It just doesn't matter, right? So the point here is polygon makes an assumption. We're refactoring code to remove the assumption. The assumption is we're going to end back up where we started. That's all you need to know.
So the whole point of refactoring, if you take a look at just the title of what we're trying to focus on. So refactoring is the art of rewriting the text of your code without changing what the code actually does.
Right.
And so, like, if you have a block of code and it's just written in a very inconvenient way for you to add in your feature, it might be a good idea to refactor it into a convenient way to add your feature in, and then you add your feature in, instead of trying to deal with the block of code as it exists at that moment in time.
I agree fully, and that's what you need to take away from this. That's exactly all that needs to be said, and that's the point that we need to labor on, right? The point is that when you make an assumption and it's baked into your code, if you remove the assumption, you can use the code somewhere else, right? That's always a good idea, because if you have two pieces of code that do two similar things, but they make assumptions, you can remove the assumption and have one piece of code that does two different things, right? Now you only have one thing to maintain. And now the question is simply, is it so complex that was worth it, or is it still pretty simple? That's what we're doing here. He's showing you this with polygons and polylines, and now we're moving on because that's stupid. But if anyone wants to talk about polygons and polylines, by all means, margaritas. Yeah. This is really important, right? And this is probably the most important thing to take away from this part of the class. It's also kind of awkward if we're going to talk about something, to talk about refactoring your code when you don't even know how to write code yet. I mean, we haven't even done strings and iteration, and he's touching on refactoring. That's a really weird sequence of chapters. Doc strings are really important, though. Docstrings are Python's method of documenting your code. You'll see this all over the place with Python. With Python, you type in 3 quote signs, and you can type in a string. You can format that string however you want. There is a specific method Python likes, because style Nazis. And what happens here is, this makes your code available to the Python help system. The Python help system is awesome. It's awesome. You'll use it everywhere, right? I'll give you case in point. We saw one module so far. Who knows what the module is? Huh? Damn, I screwed that up already. We saw one module before Turtle. Who knows what the module is? Math. Okay, much better. So we're going to do Python 3, right? I'm going to do import math, right? And now I'm going to do help math, right? And look at all of that. That's how you use math, right? Every one of those functions. I said sign is a function, right? We saw that guy in there. That was the first thing that he used. That was your introduction to functions that you didn't write. What a horrible idea. So sign is a function in the math module. You want to know how that works? You can type help math, and it shows you all of the functions in there with a brief description of them all. If you want to know how just that function works, you can say help math.sign, and you can see just that function. This is the Perl box for Python if you're a Perl user, right? So you write Python code. The emphasis is in creating this thing called a docstring, 3 quoting marks, then all of your stuff, then 3 quoting marks. You make it the first line, and then it magically becomes available in the help, right? So you go, okay, well, what's the right format that the style Nazis want? If we come down here and we jump into this code, and I just show you something here, def foo, right? I guarantee you the IDE is going to get you covered. 1, 2, 3. There you go. That's the format they like. So you type in your, what you're returning, something like this. It returns the string hello, right? And then I'm going to come down here and I would say return hello, right? And then that's what that would look like. That's a Python docstring.
So it's an equivalent of a comment with the hashtag?
It's a comment, but here's the difference between a comment and a docstring. A comment is code that doesn't run ever, right? A docstring is metadata. The docstring makes it available to everyone who uses your module what that thing does, because help knows where it's at. A comment isn't available to help. A comment is only available to the programmer. The docstring is made to ease the job of the user and the programmer. Does that make sense to you?
So metadata is kind of confusing for people who haven't ran into it before. Consider it a comment that is specifically formatted to be used by systems that make it easier for you to write documentation about your modules. So these extra quotes, that format where it has the return and colons, this is going to generate your API documentation for you.
Yep. And there's going to be whole frameworks that are based around this. This is that's something you definitely got to take away. Yes?
Okay, but it still has the same format of like a multi-line comment, though.
Yes, it does. But the first multi-line comment, right, in Python is called the docstring. It's special. That's exactly. So actually, no, right? These are not multi-line comments. These are multi-line strings, right? The triple quotey thing doesn't make it a multi-line comment. The triple quotey thing is Python's triple quote string. So you can set this, like if I do something like this, right? I can do something like A equals, right? What is that going to return, Marcel?
A.
And what is A equal to?
A.
A equals literal, right? We have this stuff up here. This is a new line test, right? So the triple quotes is a method of creating a multi-line string, right? That's the difference. So you said multi-line comment, and I'm being pedantic about this because that is an important terminology.
No, that's not what makes sense.
Right. So anytime you want to create a multi-line string, you can use this triple quote thing, and then you can put quotes inside of it. You can put all kinds of crap in there, right? And Python says we're quoting the whole thing, right? So when you do that, if it's the first line in the thing, and you're not assigning it to a variable, it's called a docstring. There we go. Okay, so and then the book says almost nothing about it. Fantastic. If you want to know more about doc strings, right, what you're going to do is just type in Python 3 docstring, and this is sadly, I think that they should have said a little bit more about it, but here you go. There's a whole convention about this, right? So these PEP things, if you really want to get into Python, you would know this kind of stuff. But this talks about, internal formatting and all of that kind of stuff and where you use them. But yeah, for our purposes, just know that the first one you use on a function or on a class or on a module is for the internal documentation, and you can read all of that stuff by typing help, and then that's your method of quickly getting documentation. Jump into Python, import the stuff, give it to help, and help will tell you about it. Okay. So, debugging. There's absolutely nothing in there about debugging. That's an empty section. Debugging is a fun topic. We'll get to it later on if the book doesn't cover it, but there's nothing in there for me to show you on it. Debugging is the process of fixing code, right? So there's a lot of different ways you can debug code. You can debug code in a debugger. You can debug code by giving print statements. You guys remember when we first introduced range? And Ed gave me the suggestion without Ed telling you what his suggestion was. Does anyone remember what Ed's suggestion was? We were showing off range. Ed said print, but print what?
0 to 3.
Print the iterator, right? Print I. That was Ed's suggestion. That's a great way to debug code because you want to know what's happening. For I in range 3. You want to debug it, know what's going on, know what I is set to with each call. You can drop a print statement in there. That's one method of figuring out what you're doing. There's an actual tool inside of your code called the debugger too, but we're going to go into that at a later point. That's not where the book's at with this. Okay. Draw a stack of your program while executing circle bob, radius. You can do this. Okay, that's not, where is this? Let's go back here to this. Here's what I'm going to do. I'm going to say here, if I see if I can get this thing to die. There we go. Okay. It wants you to draw a stack trace of what's happening each time in between. I wanted to show what happens when we have a problem, right? If we look here, this is what the stack is showing. The last call is right here. This is the arc bob 5090. This is where it's showing you the problem is. Right below it, you can see where inside of that function the problem was created. And it shows you actually the line number, line 26 in arc. If I come down here to line 26, you can see this, doc-awk. This is a problem that I put inside of that code, just to give you an idea of what your error messages look like. I called this thing arc bob 5090, and it triggered internally this, doc-awk, which doesn't exist. Python is coming back and it's telling me name not defined, right? I'm just showing you this because this is what you're going to be looking at when you actually find bugs in software. You could do what it's asking, right? Drawing a stack diagram, showing you what happens with each different step. What you're going to get, though, is something like this. This is an example of a stack diagram. The stack had nothing on it, and I called this function, arc bob 5090. That's at the top. That's what we did, remember? I said if it's at the top, that's what you're doing. And I said the stuff below it may be a source of bugs too. Right below it, we see this. This line 26 in arc, doc-awk. Name error, name is not defined. I'm doing this because I don't like the book's idea of drawing this stuff out. I'd rather show it to you how you're going to see it. This is how you're going to see it. You're going to see it like this. When you call something that breaks something, it's going to tell you what code you call, this arc component. That's right here, right? The art component is calling that line above that has something that Python doesn't understand, right? Right there. That's where it gets triggered. And Python is telling you both what you did and what the function you called did. And that's what they call the stack. Going into that deeper is just wasting your time at this point, right? That's all you need to know for debugging. Okay. I think at this point they are sufficiently in the weeds entirely, and we're going to skip it. It's 8:10. I'm going to do conditionals and a little bit of recursion, and then let Ed finish this off next week. Does that sound good? Okay, cool. Because I don't want to pursue all of that nonsense. Here's what we have. In 5.1, we have floor division and modulus. Python has this special operator. It looks like a double division sign. All that it does is truncate the division, right? So if you divide two things and you have a fractional component and you want to cut that fractional component off, use the double division sign and it goes away, right? They're showing you here minutes equals 105, minutes divided by 60, 1.75, right? So 105 is seconds. But you would never say you have 1.75 minutes. So look what they do here. They do divide, 60, right? Now you have 1. That's what you expect, right? This is, in my opinion, like, this should be chapter number 1. I don't know why we did refactoring and debugging before people know how to do this, right? Anyway, I did ask before we started the class, what is the best book to teach Python on that's free? And this was what everyone told me. So everyone that was here remembers that conversation. This is not a great ordering. But here, we do this. Remainder equals minutes minus hours times 60. Remainder, right? This is how he's figuring out the amount of seconds. So we have this thing here, 105 seconds, and we want to find out how many minutes it is, right? We take minutes, and we say divide 60. Now we have 1, right? That's the amount of hours. Now we want to find the amount of minutes that we have that aren't hours. So we're saying minutes minus hours times 60. That's going to be the remainder. So 105 is 1 hour and 45 minutes. Very simple. An alternative is to use the modulus operator, %sign. This is super important, and this is not the best way to show it off. The modulus operator divides two numbers and returns the remainder. Minutes modulus 60 is going to say, what is the remainder after you get that whole number, right? So basic math, when you make a division, you get two things back. You get the quotient and remainder. Is that the right math term? Okay, yeah, good enough. Math terms are also stupid. You get. We went over this in the last, I think in the JavaScript class. Someone actually challenged me on this, and I went through some of the math terms that we use all the time in computer programming, or that you definitely see in circles, and no one got them right. And I just pulled like 6 of them because they're always dumb. You know, if you look at something like plus, you know each side of the plus has a name. Does anyone here know what that is? Each side of an addition operator has a name.
You told me before, and it was so important, I committed it to not memory.
That's right. I want to say it's the add end on the left and the aug end on the right. And the same thing with subtraction. It's the subtrahend and the minuend. Subtrahend minus minuend equals difference. Anyway,
Subtraction, if you swap them, it makes a difference.
that's exactly, yeah, that's a good point. But yes, math terms are stupid. That's my final answer. So when you make a division, you get two things back, the remainder and something else. That's the amount of times that thing goes into it fully. I think it's called the quotient, stupid math term. But that's what the modulus is returning, the other component of that, right? So you get the quotient and you get the remainder. Boolean expressions. This is very simple. You have 2 of them. It can't get simpler than that. True and false, right? It's literally as simple as it gets. And in Python, I already made the mistake today. I had true lowercase. Python's picky about that. True's got to be uppercase. So does false. Because they're values. That's very simple. That's the rule, right? If it's a literal and you want it to be a value, it's going to be the first character is uppercase, right? And none is also that way, right? So none is also not valid lowercase. It's got to be uppercase. So true, false, If you look here, we went over this, Ed went over this, the very first class, the very first section, they hit this, the type system. You can call type and provide it any value when it tells you what type that value is of. Right? You can call type on a number and it'll say integer. Type on a float, it'll say float. Float is something with a decimal point. Right? Type on true, you get Boolean. Type on false, you get Boolean. It's that simple. What can you do with Booleans? Okay. This is not difficult. You can negate them. True negated is false. False negated is true. Right? That's simple. Flipping it. Other than that, you can essentially, in Python, you can compare them. Right? So you can compare true and false. In Python, if you say true is greater than false, you get true. Trues come before false. This is not stuff I would show in this book. I don't know what. This is stupid. You can compare any two values. Booleans are just like any other values. I don't know why he's talking about it in this context. But yes, comparison operators are very important. And outside of Booleans, they make a lot of sense. Right? If you want to take these comparison operators on numbers, it's perfectly fine. When we write code in Python, we have a lot of things called conditionals. Those conditionals will use what he's calling these relational operators. That's how you write code. So if you want to say something like, we can come back down here to our scratchpad and delete this crazy geometry stuff. Let x equals 5, right? And then I can say something like this. If x is greater than 3, put it in parentheses because it's Python 3. That's one of the things you don't do in Python 2, if anyone wants trivia points. So that's an example of code that you would write here that uses the relational operators. This makes sense. You'll see this all the time. When you want to compare the arguments you get, or you want to compare against specific values, that's how you're going to do it. You have greater than, you have less than, and you have equality. And then in addition to that, you can mix the two. You have greater than an equal and less than an equal. And that's what he's showing you right here in this. He shows you not equal to is this. It's the exclamation point equal sign. Very important. Not equal to. Greater than, everyone knows this sign from algebra. Less than, it's the other direction. Then we have greater than or equal to and less than or equal to. And that's very simple. Logical operators. There are 3 logical operators and or not. So we talked about Boolean values. We said true and false. And we talked about what we can do to them. Right? We can negate them. Here's how we can compare them. Right? We can say and or not. And how is that useful? Let's go back to our code. If I want to find if x is in the range of, let's say, 1 and 3, I can say x is greater than 1 and x is less than 3.
Yeah, hold on. You put greater than.
There we go. Right, so this is an example of where we would use this kind of the comparison operators and the logical operators. We have x is greater than 1. This is going to return a Boolean, true or false. That's how it gets simplified. On the other side, we have x is less than 3. This is going to return a Boolean, true or false. Now we have this thing in the middle, this Boolean operator, and. And how does it work? It's simple. True and true is true. Anything except true and true is false. True and false, false. False and true, false. False and false, that one's easy. You can't get true out of that, right? You can't screw that one up. So, and is very simple. Or, almost as simple, right? If either side of this is true, the result is true. Right? So, if I say this, if true, by the way, this works in Python, and I think I showed it off one time. If true, that always executes. If false, that always executes. If I do this, if false or true, what's going to happen? Execute or not?
True.
Execute. It's going to be true, right? if I say false and true, is that going to execute? No, it's not. Right? This is like the bread and butter shit. This should have been like day one stuff in the priority of it, right? But this is very important because you'll see this everywhere, and that's all that it works. And if you don't get, yes?
You said if false won't execute. Is that what you said? Or
If
does-
false, will not execute. That's right.
Okay, all right.
If I do this,
Okay.
it will not.
Okay.
And if anything evaluates the false, it will not execute. So what happens is both sides of those logical operators get reduced to a Boolean. And then that logical operator with those two Booleans, it gets reduced to a Boolean. And then if it comes out to be false, it doesn't run. If it comes out to be true, it runs. And then the whole other, the great fandango is just about simplification, right? So we look at this dance that we have going on here. You see 42 and true? That executes as true in Python because anything but 0 is true, right? So this comes down, he's introducing an interesting concept here to this idea of truthiness, right? That's a Colbert term, but computer programmers had it first. Right? So how does truthiness work? It's simple. If you give something a string or a number or a Boolean or an object or whatever you give it in Boolean context with the Boolean operator, it has to be true or false or a type error. You're going to get one of those three things is going to happen. It's either going to return true, it's going to return false, or it's going to be a type error, and your own objects will work the same way. Right? 42 is a number. Numbers in a Boolean context return true if they're not 0. Strings in Python always return type errors. Right? In Perl, they don't. They work differently. Different languages will do this in different ways. In Perl, in the great world of Perl, empty strings are false. A string with anything in it is true. A string of 0 is false too. He's gonna nail me on this one.
To the material.
Yes, I'm gonna. Okay. The point is that this is specific to Python. So when we look at some of these things that we have here, if x is greater than 0, x is positive. That one's simple, and he's showing you that it's just simply gets reduced to true, and then that code runs. The alternative execution. We can branch off based on something that doesn't always happen, right? If we look over here, and we say if x is greater than, let's say, 7, this is not going to run, right? Because x is equal to 5. But what you can do is you can say here, else. That gives it something else that will run. Now every time this condition gets hit, one of these two blocks of code is going to run, the top piece or the bottom piece. Right? So this is a conditional statement, but there's an else in it. So you're always going to be triggering one of those two things. That's the alternative execution. Right? Okay. And then he talks about chained conditionals. What if you want to have more than one example here? Like if I say if x is greater than 7, print x is in our range. What if I want to do something like this? Else if x is less than 9 and x is greater than, no, x is greater than 5. There we go. This is a better idea. X is close to our range. If I run this code, x isn't in our range, right? It's not greater than 7 because it's 6. But it's greater than 5, so it's going to say x is close to our range. Right? And then if it's not greater than 5, it's just going to say x is not in our range. So if I run this code, run, x is close to our range. But if I come up here and I show x equals 1, what happens there? It's not in our range. This is how examples should be. They shouldn't involve geometry. It's very simple. You have if you have else if, and you have else. And then those are flow control statements. They have conditionals, right? Nested conditionals. This just brings up the complexity one small notch. We have in here if, else, right? Now we say this is, one of these two things is going to happen. You're either going to print x is not equal, or you're going to do all of this crap inside, right? That's just nesting. When you create an if statement, the block inside of that if statement can have anything in it, including other if statements. If it has another if statement, it's considered a nested if, right? Now, sometimes you can unnest those ifs. So if you take his code right here, let's look at this. We're just going to paste it. Boom. This is his code, right? Make it a little bigger for the people in the back. We have if x is greater than 7, if x equals y, x and y are equal, else if x is less than y, print x is less than y, else x is greater than y. So we have to have a y in here too, right? So y equals 9, x equals 9. This is our code. X is greater than 7, x and y are equal. This is what it's going to do, right? If I run this code, run. Did I screw something up?
Last line needs to be indented.
Oh, jeez. There we go. X and y are equal. Now here's the question. Can we make this cleaner? Yes, we can. How can we make it cleaner, right? Let's get rid of this else entirely, right? It doesn't even need to be there. We can just take this. We can go Shift Tab, and I can go here. If this thing would stop stinging me. There we go. Else, elif, Python. If x is greater than 7, if x is equal to y, else if x is less than y, else x is greater than y, right? Generally speaking, you don't want to nest your stuff unless you have to, right? Yeah?
Is there a limit to the number of times you can use else if or else?
No. If there is, it's absurdly high.
If you start finding
Yeah.
yourself using else if like 8 or 9 times, you're probably using an approach that is not a very good approach because it becomes very hard to make changes.
And else also can be repeated any number of times?
Well, no, else is if none of the conditions above happened, then do else. So you can only have one else.
Yeah. Python doesn't have switch statements, so sometimes you do see else ifs a lot, you know. But yeah, anyway, the point is that there's no limit. So keep using them to heart's content, and there's more or less nothing wrong with it. You'll see them sometimes in Python code quite lengthy. But one thing that you do want to be attentive to is this nesting idea. If you have else and then another if right after it, you should consciously be thinking, do I need that? Right? And you usually don't. Someone may ask, when do you need it? Right? For shits and giggles. Let's talk about that. That's certainly on topic here. So you would need it if you do something inside of the else statement. Right? Like let's say you do this. U equals 10, and then you want to print x is less than y, and u is there you go, right? So this is a case right here where you could use it. Because what are you doing here? Bigger. You are, there we go. What you're doing here is, inside of the else statement, you're doing something special, right? You're creating a new variable called u, right? Or you're doing something else. You're doing something else that's unique to those two pieces of code. So if you need to do that kind of stuff, then you can have a nested else statement. Yes?
Earlier you were talking about scope. If that thing is, the else thing is triggered, is that local variable?
No, because Python doesn't scope to conditionals. But we're not going to get into that yet because we're going to stick at least somewhat to the material. And I don't want to get too lost in the weeds. Or actually, it's not the weeds. That's the important shit. I don't know why it's taking us so long to get to it. So we have here, if 0 is less than x, if x is less than 10, print x is a positive signed digit, right? That is a very verbose and ridiculous way of saying this. This is clean, right? He's showing you this is stupid. This is a good idea. Don't do this. if you have one piece of code you need to trigger, you can write it as a compound if statement using AND. That's what it's there for. It's your friend. Moving on, recursion. I'm going to hit recursion and then leave it off. We're going to be done. Okay, recursion is really cool. If we take this thing called countdown and we give it an n, right, we can actually have that function countdown call itself. When is this useful, right? It's useful when the function knows when it should not call itself. So think of it a different way. A function can call itself so long as baked into that function there's a terminal condition, a point in which it no longer calls itself. The terminal condition is what you need to look for when you see recursion, and you need to be thinking about it. If you write recursive functions, you need to think, when does this stop recursing? With this function countdown, it's very simple. You're going to keep counting down until n is 0, right? You never go the launch of the spacecraft t minus 3, 2, 1, 0, negative 1, negative 2. You'll be there all day. So the point is you can keep calling that function countdown, which tells it, okay, I need to go down one more, so long as you know when to stop. Ed?
Unfortunately, that's a really bad example because they actually do.
Okay. But we're sticking to the material, and in an ideal world, they wouldn't.
I know he's saying.
Okay, guys. So, yes. What we're going to do is I'm going to pop this guy right over here, and I'm going to show some of the stuff off. This is actually not too bad, so long as you always think to yourself when we come to the recursion, what is the terminal condition, and am I approaching it? As long as you get that through your head, that there has to be a terminal condition, and you have to be moving towards it. If you can clear those 2 points, you can wrap your head around recursion. So here's what's happening here. When I call countdown, right, and I give it countdown 10, right, and we're not in Ed world, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off, unless you're Ed. So the point here is that the condition is right there. N is less than or equal to 0. That's how this one works, right? And what we're doing is, let's go through it and let's think about this for a second and reason about this code. Because this is the first time we've seen this, and this is a huge concept in programming. Countdown n minus 1. That's our key. That's what approaches that condition. When we call it the first time 10, is 10 less than 0? Who's the bright whippersnapper? No, 10 is not less than 0. Good job. So what happens? We don't trigger this, right? We trigger what this author is calling alternative execution, which is goofy. We're triggering the else statement, right? What does the else statement do? Prints it. What is it going to print? 10. Simple. What's going to happen here? It's going to call countdown, but what is it going to call it with? 9. 9? Countdown. Is 9 less than or equal to 0? Not you. I know you've got it.
No.
No. Okay. Good. 9 still less than or equal to 0. So greater than or equal to 0. So what happens? Triggers this. Prints 9. Countdown. 9 minus 1. Who wants to do it? 8. Right? 8. Then we call it again. And so on. 8, 7, 6, 5. Okay. Now we get down to our glorious 0. Is 0 less than or equal to 0?
Yes.
What is it going to do here? Blast off. And then it's done. Now here's the thing. Each time it did this, right? Each time it did this, we push something onto a stack. And now is where the stack becomes somewhat important. The first time we called it, we have one function called countdown, and n is equal to 10. The second time we call it, we have something else on the stack. Now n is equal to 9. The third time we call it, we put something else on the stack. Now n is equal to 8. Each time we call it, we get a different copy of n, right? So n is equal to 10 is on the very bottom of the stack. That's gone very quick. You don't have access to it when you get to 9. You don't have access to 9 when you get to 8. You don't have access to 8 when you get to 7. Each time, countdown gets a different n, right? Until it gets to 0. Now you're at 0 at the top. You've just printed off blast off. What happens now? Okay, well you printed blast off. Now blast off is done. But you return right here. This is where it's going to kind of blow your mind the first time you think about it. You call the function. What happens when you call a function? You return when you're done with it. where do you return? To the end of where you called it. Watch this. Let's print something after this recursion, right? I want you to think about it. What's going to happen now after we do this? Unwinding. Okay. What is that going to do? So when we call it the first time, let's say we get down here. Let's just do it for something simple. 1. Right? We call countdown 1. What happens? Is 1 less than or equal to 0?
No.
I love you. You're so good on this. Okay. We move down here, right? Now we're going to print 1. We're going to call countdown 0. And when we get done with countdown 0, we're going to call this guy. Right? That's where it's going to return. So just like any function, when you're done with the function, you go to the line after it. It's not complex. It's only complex because we're doing this to ourselves, which is fun and matrixy. So when we call this, right, we had 1. We just printed off 1. Now we're calling this with 0. 0 is less than or equal to 0, right? We're going to print blast off. This countdown 0, is the same thing as printing blast off. Countdown 0 is blast off. That's it. If I give you countdown 0, nothing happens except printing blast off. You may as well just call another function called print blast off. And you don't even have to call it, right? I mean, you could rename that terminal condition whatever you want or call something else for it. But now you're here, countdown 0, blast off. So we have print 1, print blast off, print unwinding 1. Okay. That's recursion, right? And it's going to take that a little while to sit in because that brings together everything. It brings together the parameters up at the top, these arguments. Brings together this idea of a function calling itself. It brings together this idea that the variables provided in that function are local to that function. And even if you call it itself, again, the variables that you get are still local to that function, that call of that function. Every time you call a function, you get a different copy of those variables. Recursion brings together all of these basic concepts, right? Let me think of something else here. I'm going to show you some easier ideas here. First thing, let me show you how this runs. Run, scratch.
String M.
God, Python, man. Okay. There we go. Python debugger extension. What? No. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Boom, we're done. Now what happens? They all start to come off. Remember, I said each time we do it, we push something onto the stack. We push a new stack frame on with a new local variable. Now we're up here at the top. I said the top is close to you. That's the last thing that gets executed. Well, now you got all this shit on the stack. And someone's got to pull it off. So what happens is the function starts to roll that stuff off because it's complete. The countdown is done. So the first one returns. And what happens when the first one returns? It prints this, unwinding. Where does it start? Unwinding 1. It's got to go all the way from the first one to 10. Remember? You started off on 10. You started stacking things up till you got to 1. Then you got to the terminal condition 0. You're not going into the negatives. Now what happens? You're going down from 0 all the way down to the 10. That's what you're seeing here. Blast off, which is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We called countdown with 10. And each time we recursed, what we did is we went into ourselves and we approached that terminal condition of 0. But every time we approach that terminal condition of 0, we push something onto the stack, and then they all start to come off the stack when they're all done. Right? Now this is where the stack trace really comes in handy. Yes?
Are you saying that it actually, that your print statements, your extra print statements there are actually showing what's happening? Stored these 10 layers.
That's exactly right.
It's finished its job. It's got the blast off, and it's simply going to
unwind
remove all of them so that it could do something new someday.
Precisely.
And you stuck a print statement into that removal process so you can get a view of it.
Because I don't want you to think that recursion just happens as you're calling the function. Whenever the function is done being called, you can have shit after that call. And this author did this in the worst way possible. I mean, we could even critique it. The geometry functions in there are totally whack, right? Where he has like double recursion in there, and he doesn't make this concept very clear. This is the concept you need to understand, right? You need to understand this. You need to drill this into your head. When you're done with the call, stuff can happen after it, right? And sometimes in recursion, stuff does happen after it. Like if you're drawing, complex collegiate fractals, like he does. But when that stuff happens after it, it happens in the reverse order. Why? Because you start off on 10, you push up to 0. That's your terminal condition. Now you have stuff at the end, after you made the first call. You start to hit those things at the end, right? That whatever you want to call it, the code that remains after you recurse.
So in theory, that's just memory clearing up. That's like what Chrome doesn't do.
Well, that's a whole other thing. But if you don't clean this stuff up, you can have problems, right? So this is the function finishing its call. And that finishing of that function call can clean up. Yes. So if I did something like here, we could say something like here, open database or whatever, and then I call itself and I want to close the database handles, clean up the stuff. Yes, if you don't run whatever happens after that recursion, bad things can happen. Okay. Yes, we have a couple questions.
Okay, so maybe I'm either going too fast. So the way I understood it is you have your definition, and then if you run what's under the if.
Right.
If it's not under the if, you run under the else. So what I'm confused as, you've gone through everything and you finally get your ifs. You wouldn't run what's under else because you ran what's under if, correct?
You wouldn't run what's under. That's right. For the first case,
So,
for the 0 case, the terminal condition.
Right. But then your print is under the else. So why is that at the end? Is that not actually under the else?
Bring the print out, it would be less confusing. Undent the print, last print.
Okay, so that's not actually under the else.
Either
No,
way.
it was, but it doesn't have to be. That's what he's saying, right? So here's the difference. If I put it underneath the else, I do not get it on the blast off condition. Notice here, blast off, we don't show n equals 0, but we run n equals 0. When n equals 0, all we do is print blast off. And I was doing that because I thought it would make it simpler. But we don't have to just do blast off. I can print something below it. Now the function when n equals 0 will run this. Now you're going to see at the bottom, blast off, n equals 0. And then you're going to continue. Right? So watch. Notice here, blast off, n1. What I did is I moved the print statement from here to here. Now watch what happens. Run, scratch. Oh, run. What am I? There we go. I have no idea what just happened. But yeah, blast off, n equals 0. So when we put the statement here underneath the else, we didn't run it for n equals 0. If we move it outside, we run it all the time because it's no longer subject to this conditional. So this conditional is only going to run the code, right, when n is greater than 0. If I wanted to run the code unconditionally, move it outside of the if else. Now it's going to run on either this or this, right? Because all of this stuff outside of an if else runs.
So why is it at the very bottom and not in your countdown?
Why is it? Because I wanted it to show what happens afterward. So I needed to show what happens after this code gets run.
Okay.
Right? Because I want to show the stack unwinding. Right? The winding up component everyone gets. Everyone gets, you start off with 10, 9, 8, 7, 6. Everyone gets when you get to 0. That always clicks. I did this in the JavaScript class. Everyone got it. But then you say, okay, well, you still got all these 10 function calls you got, and you can have code after the call. What happens with the code after the call? You go back down. Right? And as you go back down, this is what would get triggered. And I wanted you to see that too. Now here's the catch. This is where stack graphs can come in handy. Right? And he has, I think, maybe one decent one in here. He does have a couple? There we go. Right here. So here's how he's showing this. The execution of the countdown. By the way, I don't think there's anything in Python that gives you this. So you got to write this, or this is one way you can do it. You can write this out. And this is him showing you how he's writing it out. Right? So this is different from the stack dump when you have a problem. This is him tracing through recursion. So he says here, the execution of countdown begins with, let's see here if I can make that bigger. There we go. There we go. Okay. The execution of countdown begins with n equals 2, and since n is greater than 0, it outputs the value 2, and then it calls itself. The execution of countdown begins with n equals 1, and since n is greater than 0, it outputs the value of 1, and then calls itself. The execution of countdown begins with n equals 0. And since n is not greater than 0, it outputs the word blast off and then returns. Now we're still in this above function where n equals 1. n equals 1 has not returned yet. So the countdown that got n equals 1 returns. The countdown that got n equals 2 returns. The countdown that got n equals 3 returns. So I want you to understand this step right here, that these functions still have to return. It doesn't end with blast off. Okay. It is 8:45. I think we are done, and that means that Ed will be taking this from the next class through infinite recursion, keyboard input, and debugging, and running a few chapters after that. Does anyone have any questions over what we covered?
So like about recursion, because it has to unpack all that stuff after the code run, does it take up like twice as much memory?
Recursion, this is a good question. It doesn't take up twice as much memory. Does recursion take up memory? Yes. And can you recurse infinitely? No. And Ed will be covering more of that in the next class. Recursion, the fact that n is a value, right? Let me show you something here. When we did this, we went from 10 to 1 and we got blast off. But n's didn't go away. They exist. And in a complex recursive function, there can be a lot of shit, not just an n, right? So the question is, does it take up memory? It certainly takes up memory. When a function calls itself, it didn't forget everything about it running. It's still waiting for the function that called itself to return, right? And until a function returns, the memory's not gone. If something happens after it calls itself, that's not gone until the function returns.
The function actually crashes on my computer between blast off 900 and 1000, and it says that there's a maximum recursion depth.
Right.
Is that set by the interpreter or your physical and virtual memory?
cPython.
Okay.
Yeah, because your physical memory would permit, hundreds of thousands or millions. But if you're recursing more than 1,000 times in Python, you have a problem. Some languages use this everywhere. Yeah. Does anyone have anything to add to that or any more questions? Yes.
I just want to reiterate the recommendation I gave earlier about the Python crash course book.
Yeah.
Because I went through this book in the last hour or two, and that Python crash course book has a much easier flow than this book. And it's only $27 on Amazon. It's well worth the $27, believe me.
I think it's a valid point. I think the big thing about this class is we wanted to focus on material that is free and open source, so I could rip it off and make my own slides, right? And so I could put videos on YouTube and all of that kind of stuff. But is this the best material on Python? Absolutely not. If you have $30, would I spend it on this book or something else? If you're learning by yourself, absolutely something else. I welcome those comments. And I welcome someone else that evaluates this stuff to show me if there's better, freer material online elsewhere. Anyone else have any questions?